Hello, hi everyone. Welcome to the next video of this one-shot series. In this video, we are going to discuss some previous year questions of aldehydes, ketones, and carboxylic acids. Important questions of aldehydes, ketones, and carboxylic acid. The chapter is big. We have so many name reactions, right? And you should know the mechanism of certain reactions also. Then only you get the correct answer. I have divided the entire chapter into the 6 topics from which the questions can come. Like first, we are going to discuss questions which are based on GOC concept and reaction mechanism concept. Second, we are going to discuss questions which are directly from the preparations of carbonyl compounds and carboxylic acids. Then physical properties, then chemical reactions of carbonyl compounds, chemical reactions of carboxylic acid, and after that we have questions which are based on the distinguish test. It means if you want to identify aldehydes from ketones, yeah, if you want to distinguish aldehydes, ketones, and carboxylic acid, so we have certain tests. We have certain tests which is a part of practical organic chemistry, but we are going to do all those questions in this chapter. Okay, so let's start our video in a systematic manner. So first we are going to discuss the weightage, then syllabus with the help of mind map, and then we will solve previous year question. So when I try to solve previous year question, I will tell you the hint, or I will tell you how to get the correct answer. So who will benefit from this video? Who knows the basics? It means NCERT is mandatory. NCERT is mandatory, but some important tricks you should know, right? And you should know the mechanism of some important reactions, right? Mechanism is also very important. For that, yes, coaching part is very important in this chapter, but right now this is not a important time, or this is not the high time to take coaching and to revise all these things, right? Because this is not the right time. So what you can do, I'm going to discuss how to solve the questions using tricks. So just try to memorize well and try to apply these similar tricks in similar kind of questions. Okay, so that is the important thing. So NCERT level knowledge and has taken coaching somewhere. So this video is only for those students, and you should practice well. You should do the revision before seeing this video. Otherwise, it will not be fruitful to you. Okay. How to use this video? You have to revise short notes. You have to write down the important information. Write down the mechanism of some important reaction, mechanism of important reaction, and then you can start practice. Now weightage, it is the one question is going to come at an average. Might be in some set we can have one question from carbonyl compound. We can have one question from carbonyl compound and one question from carboxylic acid. Okay, so we can have two questions. Okay, now if I'm going to discuss the mind map over here, so in the mind map we have the preparation. Okay, we have the preparation of carbonyl compounds, aldehydes and ketones, and carboxylic acids. Carboxylic acids. Then we have physical properties with respect to boiling point, melting point, solubility in water with respect to carbonyl compounds and carboxylic acid. Then we have chemical properties. So we know that carbonyl compounds, they generally undergo nucleophilic addition reaction, right? Nucleophilic addition reaction. So you should know the mechanism of simple nucleophilic addition reaction. Now in carboxylic acid, so carboxylic acid, they behave like acid in most of the reaction. Now in the carboxylic acid, we have one important topic, that is the carboxylic acid derivative. Which? Carboxylic acid derivative. Ek minute, let me write it. So we have chemical properties, physical properties, preparation. Then we have distinguish test, carbonyl and carboxylic. Then we have derivatives of carboxylic acid. So derivatives of carboxylic acid, it includes amide, ester, acid chloride, or we can say acyl chloride, and then we have acid anhydride. So you should know the preparation properties of these derivatives of carboxylic acid and the chemical reaction with respect to that. So this is the important part with respect to mind map. So let's discuss type 1 questions. Now type 1 questions are going to be from the basics, GOC and the reaction mechanism concepts. So let's do it. Question number 1 says the correct decreasing order of acid strength is. So we know that acidic strength is directly proportional to Ka, inversely proportional to the value of pKa, directly proportional to electron withdrawing group, inversely proportional to electron releasing group, or directly proportional to stability of conjugate base. Okay, so now in the question we have NO2CH2COOH, we have NO2CH2 and this is C double bond OH. ठीक है, then we have FCH2 C double bond OH, then we have C triple bond N CH2 C double bond OH, and last we have Cl CH2 C double bond OH. Now how to solve this question? So first what we are going to do, just remove hydrogen H plus. So when you remove H plus you get negative charge on O minus. When you remove H plus you get negative charge on O minus. Now same negative charge on O minus and negative charge on O minus. Up now we need to find out the stability of conjugate base which is formed after the removal of H plus. Okay. So if we have acid, suppose if we have acid HCOOH, so after the removal of H plus we get HCOO minus plus H2O positive. So if this is acid, so this is going to be the conjugate base. Now conjugate base, it contains negative charge or it has negative charge. So negative charge is stabilized in presence of electron withdrawing group. Now what are electron withdrawing group? Electron withdrawing group which are going to be like this X double bond Y, which are going to be like this X triple bond Y, or which are going to be like this X positive. Right, so these are the ways by which we can identify electron withdrawing group. So Cl more electronegative atom. So yes, it will show what? It will show inductive effect, minus I effect. ठीक है, minus I. Clear? Or we can say that this is alpha carbon. So at alpha carbon we have chlorine is present. So this chlorine can even show, if this is chlorine, so what we are going to do, acha now, just forget about this, do not consider this. We can take this is going to be minus I effect because electron withdrawing group. Then CH2 C triple bond N. So this is sp hybridized carbon atom. So this also shows minus I effect, and this is going to be electron withdrawing group. Then again fluorine shows minus I effect, and NO2 also shows minus I effect. Yani all are electron withdrawing group. Now which one possess maximum electron withdrawing effect? So the maximum electron withdrawing effect is going to be of this. Okay, NO2 nitrogen and we have 2 oxygen. ठीक है बेटे. Then we have C triple bond N, then we have fluorine, and then we have chlorine. ठीक है. If we want to compare, so this is going to be the correct order. So how to say ki the correct decreasing order of acidic strength, that is going to be the option number 4. NO2CH2COH, then CnCH2COH, FCH2COH, and ClCH2COH. Okay, is it clear? Now, moving on to the next question. The increasing order of the reactivity of the following compounds in nucleophilic addition reaction is. So, we have propanol, benzaldehyde, propanone, and butanol. Propanol is CH3, CH2, C double bond OH. Benzaldehyde is benzene and we have C double bond OH. Propanone is CH3, C double bond O, CH3, and butanone is CH3, CH2, C double bond O, CH3. Understood? So now we have to find out what is the order of nucleophilic addition reaction. So if we have carbonyl group, then nucleophile can attack on this carbonyl carbon. Why? Because this bond is polar. This bond is polar. Oxygen carries delta negative and carbon carries delta positive. So nucleophile can easily attack onto the carbonyl carbon and we can have the nucleophilic addition reaction. Okay, we can have nucleophilic addition reaction. So if carbonyl carbon is more electrophilic or less nucleophilic, then nucleophilic addition is faster. Nucleophilic addition is faster. So we have to apply this concept in order to find out the correct answer. So see, what we are going to do, see, we have aldehyde, so aldehyde mein we have one electron releasing group, CH2 CH3. So one electron releasing group is there. Okay. If you take benzaldehyde, so again one electron releasing group is there. If you take ketone, so we have two electron releasing group. And if you take butanol, so we have two electron releasing group. Understood? We have two electron releasing group. So the point is, which one is more electrophilic? So obviously aldehyde or in aldehyde carbonyl carbon is more electrophilic. Okay bete, electrophilic. So first is going to be propanol, then we have benzaldehyde, then we have propanol, and then we have butanol. Understood? Then we have butanol. Is it clear? We can also find out ki, see, the phenyl group, in the phenyl group we have more resonating structure, right? Here we can form more resonating structure, or phenyl ring, right? Phenyl ring is better electron donor, in comparison to alkyl group. So first of all the propanol hai. So we have two option number 1 and option number 2. And after that we have benzaldehyde. We cannot have propanol. Why? Because in propanol we have two electron releasing group. So if we have two electron releasing groups, then this carbonyl carbon is going to be less electrophilic. Okay, so on the basis of that we can take the option 2 as the correct answer. Okay, now moving on to the next question, the increasing order of the following towards HCl. So HCN addition happens in the basic medium. So what happened? HCN in the presence of basic medium gives Cn minus plus water. Okay, OH minus takes H plus. Okay bete. Up now it means we have to find out in which nucleophilic addition is faster. Okay, we have to find out in which nucleophilic addition is faster बच्चे. ठीक है, तो same thing. So nucleophilic addition is faster where ring is electrophilic. Now if you see the options in the ring, we have certain groups. Like in the first we have OCH3, in second we have NO2, then OCH3, and then we have NO2. ठीक है. So for electrophilic character, we can say that nucleophilic addition is faster in presence of electron withdrawing group and inversely proportional to electron releasing group. Okay, so this is CHO, C double bond OH, and here Cn minus is going to attack. Okay, up now at ortho position we have NO2 group. So at ortho position we write minus M effect, mesomeric effect. Okay, now here we have ortho and meta. So meta position pe we write minus I effect. Minus I effect is dominating because resonance effect is observed only at ortho and para position. So whenever we draw resonating structure, negative charge and positive charge comes only on ortho and para position. It does not come on meta position. That's why on meta position inductive effect dominates, while ortho and para position mesomeric effect dominates, right? So here we write minus I. Why minus I? Because nitrogen is more electronegative. So here we have minus I. Now we have OCH3. Oxygen has lone pair. So it gives electron to the system. And we have plus M effect. Again OCH3 at meta position. So here oxygen is more electronegative. So we write minus I effect. Understood? Because meta position we have to check inductive effect. So minus M effect is more dominating if we talk about the effect. So first aromatic effect, then we have mesomeric or resonance. Mesomeric and resonance, they are same thing. Then we have hyperconjugation. Then we have hyperconjugation, and then we have inductive effect. Okay. So mesomeric, resonance, hyperconjugation, and inductive effect. So minus M, so it means it withdraws electron more. So nucleophilic addition is faster in second. So now on the basis of that, we have option number 1, 2, and 3. So it means we have to find another thing. Now we have fourth option. In the fourth option and the first option. First option is correct. Now first and fourth. So in first and fourth, nitrogen is there and oxygen. So oxygen is more electronegative, right? Oxygen is more electronegative. And here we have nitrogen. Here we have nitrogen. Nitrogen is less electronegative. Nitrogen is less electronegative, right? Up now, nitrogen is bonded to oxygen while oxygen is bonded to CH3. Understood or not? Nitrogen is bonded to oxygen, and in that one, oxygen is bonded to CH3. CH3 is that group which gives electron. CH3 is that group which gives electron. So oxygen cannot take more electron from the phenyl ring. While nitrogen is bonded to oxygen, so if nitrogen is bonded to oxygen, so oxygen has tendency to take electron. Oxygen has tendency to take more electrons. So in that, what we can do? First is going to be second, and then we have option number fourth, right? Then we have option number fourth. After that, we have option number 1, and then last we have third, because that is going to be the mesomeric effect. So answer should be this one. Clear or not? Clear? Now, moving on to the next question. In the following reaction, carbonyl compound plus MeOH in the presence of HCl gives acetal. So what happens? Acetal is formed from aldehyde. Acetal is formed from aldehyde. So if we take the example RC double bond OH in the presence of CH3OH and dry HCl. So what happens? Dry HCl है तो oxygen first takes this H plus. ठीक है, तो we have RC double bond दो OH positive H. Okay, now what happens? OCH3 minus attacks on this carbon and electron of this bond shifts to oxygen. So we get RCOH. Here I can write H and OCH3. So this is called hemiacetal. Hemiacetal. Now what happens? RCHOH OCH3 on further reacts with CH3OH and HCl forms acetal. So we get OCH3 and here we can write OCH3. Understood? So this is going to be the acetal. Up question is rate of the reaction is highest for when acetone as substrate and methanol in excess. Acetone, we cannot have acetone because acetal is formed from aldehyde. So this option is incorrect. Fourth option is incorrect, right? Now we have to check option number 2 and option number 3. Propanol as substrate, okay. Methanol is stoichiometric amount, yani methanol is stoichiometric amount, because we know that if we have propanol CH3 CH2 COH, so we actually requires 2 mole of CH3OH and then dry HCl, okay, to form ethanol. Okay, so it means we can form acetal. But question is rate of reaction is the highest form. So when propanol as substrate and methanol in excess. So when we take methanol in excess, so as per Lee-Chatelier principle, reaction moves in forward direction, right or wrong? Reaction moves in forward direction. Because now concentration of reactant is more and reagent is the part of reactant. So we can say that rate of the reaction is highest for when propanol as substrate and methanol is in the excess. So this should be the answer. Clear? Now moving on to the next question. The decreasing ease of alkaline hydrolysis for the following esters. So what happens? See, if we have ester, RC double bond O and OR. So in the presence of OH minus and water, so we are going to do hydrolysis. So OH minus attacks over here. Electron of this bond shifts over oxygen. So we get O minus, OH and OR dash. Now what happens? O minus electron comes over here and OR leave. Why? Because this is a leaving group. And how to identify leaving group? Which starts from O. Like OR, O, C double bond O, CH3, or we can say halogen, or we can have NH2. So these are all leaving groups, right? These are all going to be the leaving group. So what happens over here? So we get RC double bond O, OH. So basically in this nucleophilic addition happens. Nucleophilic addition happens. So question says decreasing order of ease of alkaline hydrolysis. So see, this is the ester part, this is common. Ester, ester, ester. Now we have to check group. So Cl, in the Cl, which effect is dominant? Which effect dominates? Inductive effect. So here we have minus I. In N2O, but at para position, so we have minus M effect. Minus M effect. It means resonance. See, if we have N double bond O and this. So electron of this bond shifts over here and electron of this bond shifts to oxygen. So we can form our resonating structure like this. O minus double bond and this is going to be positive. Okay, bete? Clear? This is going to be positive. So this is basically minus M effect. OCH3 we have lone pair. So this shows plus M effect. So this is going to be electron releasing group. For nucleophilic addition, carbonyl carbon should be electrophilic. So this is going to be electrophilic in case of third. Most electrophilic in case of third. So we have two options, option number 1 and option number 2. So third is going to be most electrophilic. Then we have second, because minus I factor, it also withdraws electron from the system. So third, second. Then we have first, no group, and then we have fourth increases the electron density onto the carbonyl carbon, due to which nucleophilic addition is slow. Okay, clear? Now let's do next question. Which dicarboxylic acid is in presence of a dehydrating agent is least reactive to give an anhydride? So what happens if we have basically carboxylic acid, RC double bond OH. Let me write 2 molecules of carboxylic acid. Now in the presence of any dehydrating agent, you can say P2O5 heat, right? You can also take concentrated H2SO4 and heat. So these are all dehydrating agents. So what you need to do, just remove water. So when you remove water, so you get anhydride. Okay. So it means to form anhydride, we require 2 carboxylic acid group. So we have to remove water. So what happens? Let's remove water. HO. So when you remove water, so you get CH2, 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 CH2. Now C double bond O. Okay. Or let me write like this. CH2, C double bond O, and this is O. Okay. So we have 1, 2, 3, 4, 5, 6, 7. We have 7 member ring. 7 member ring. So we can form 6 member ring, 6 member ring and 5 member ring. Not 7, not 7, not 8, not 4, not 3. We are not going to form. Under normal condition we cannot form. Until and unless we do not have any other option, we cannot form 7-membered ring. So if you remove water, so H or O, so you get 1 2 3 4 5 membered ring. So we can form this. When you remove water from here, just remove water from here, so you get C double bond O, C double bond O, and this, so you get 5-membered ring, right? You get 5-membered ring. So here 5-membered ring, so possible, 5-membered ring possible. When you remove water from here, so you get 1 2 3 4 5, 5-membered ring, 5-membered ring. So this is also possible. So which of the following dicarboxylic acid is least reactive to given anhydride? So that is option number 1. Clear? That is option number 1. Now let's do some question which is based on the preparation of carbonyl compounds. Okay, let's do it. Which one of the following carbonyl compounds cannot be prepared by addition of water on an alkyne in the presence of HgSO4 and H2SO4? So which one of the following carbonyl compounds? So this reaction is actually the Kucherov reaction. Kucherov reaction. So what happens in Kucherov reaction? So if we have HC triple bond CH, okay, HC triple bond CH, in the, when they react, right, when they react in the presence of water, H plus, so what we can do, on one carbon we write OH, then double bond, on another carbon we write hydrogen, OH and H. So that is as per Markovnikov, as per Markovnikov. But here we have symmetrical alkyne, so there is no need to apply Markovnikov or anti-Markovnikov, but the concept is that we have to add as per the Markovnikov rule. So here this is the enol form. Now enol form is tautomerized to keto form. So we get HC double bond O, and here we write CH3. So we get aldehyde. Okay. So from ethyne we get ethanol. From rest of alkynes, we get ketone. We get ketone. For example, we have CH3, C triple bond CH. Now H2OH plus, so we have to do Markovnikov addition. So OH minus we are going to add on middle carbon. So we get double bond CH2. Now it is tautomerized to CH3, C double bond O, CH3. Okay. So the point is that we can only prepare ethanol. Now here it is aldehyde, but this is propanol. So we cannot prepare. Understood? So this is going to be the answer. This is ketone, we can prepare. Ethanol, yes, we can prepare. And this is butanol, yes, we can prepare. Understood? So there is no need to check. Just you have to learn from ethyne, we get ethanol or aldehyde. From rest of the alkynes, we get ketone. Clear? Okay. Now moving on to the next question. We have this situation. The major product obtained in the following reaction is a. So this is third butoxide. Okay? Third butoxide. So third butoxide CH3, C, CH3, C, CH3, and this is O minus K plus. This is potassium third butoxide. So we have Br and this. So third butoxide main role is to abstract beta hydrogen. So see, we have alpha carbon is this is beta carbon, this is beta carbon with respect to this bromo group. So up now in beta carbon we have two hydrogen, two hydrogen, 1 2 1 2. Okay. So the point is, if this base, this is the base, if this base abstract this hydrogen, then electron of this bond shifts over here and Br leaves. Okay. So we get this compound. Okay. Now, if base abstract this hydrogen, then electron of this bond shifts over here and Br leaves. So it means we get this. We get this. Okay. In this we have resonance. In this we have resonance. In this we have no resonance. Why do we have resonance over here? Because alternate double bonds are present. Alternate double bonds are present. So this compound is going to be the major one. Clear? Now next, we have O3 and Me2S. O3 and Me2S. This is ozonolysis. Ozonolysis. Ozonolysis, and if we have dimethyl sulfide or we can even have zinc H2O, so they are reductive ozonolysis reagent. Reductive ozonolysis reagent, and from reductive ozonolysis we can either get aldehyde or ketone. What we are going to do? Just I am going to tell you trick. Just break this bond. Put oxygen and oxygen. So let me write. So here we have carbon double bond. Then this. Acha, now you have to break this one. So here put oxygen, here put oxygen. ठीक है बेटे? So we can write this, then double bond. We do not have any methyl group, so just put hydrogen. So here you can put hydrogen. ठीक है? So one is 1, 2, 3, 4. ठीक है? So that is the 2 aldehyde groups. Okay, बच्चे? So we have one compound is going to be like this. Second compound, if I write this compound, it contains 2 carbon. So we write C double bond OH and C double bond OH. Clear? So we have 4 carbon, 1, 2, 3, 4 and 2 aldehyde group, and we have 2 carbon aldehyde group. So answer is going to be option number 1. Okay. Now moving on to the next question. The major aromatic product C in the following reaction sequence will be. Okay, reaction sequence will be. So we have this. O, this. ठीक है बेटे? Then we have HBr in excess. HBr in excess. So HBr is going to have 2 roles. One, HBr can react with ether. So oxygen lone pair takes H plus and Br leaves. And another molecule of HBr breaks this double bond. So here we are going to follow Markovnikov. Here we are going to follow Markovnikov. So when we follow Markovnikov, so this double bond takes H plus, Br leaves and Br attacks on this carbon. ठीक है बेटे? So let me write this. So we get OH positive, then this is methyl group. Here we write Br, here we have this. ठीक है? अब now first Br minus can attack on this carbon and electron of this bond shifts over here. We have discussed these reactions in alcohol, phenols and ethers. So we get OH, Br, CH2, CH, CH3 and here we write Br. Clear? Here we write Br. Now next part. We have alcoholic KOH and then H plus. So what is the role of alcoholic KH? Dehydrohalogenation. Dehydrohalogenation. So it removes beta hydrogen and alpha. It removes beta hydrogen or it removes hydrogen from beta carbon and halogen from alpha carbon. So that is the basically use of alcoholic KOH. So what happens over here? So this is alpha, this is alpha, this is beta, this is alpha, and this is beta. Okay. So first we have alkene over here and we have alkene over here. Okay, bete. So we can form this compound. This is OH. Here we write double bond, then double bond. Okay, fine. Now next, O3 and ZnH3O positive. O3 and ZnH3O positive. So this is ozonolysis. O3 and then ZnH3O positive. Okay. So what we are going to do? Just break. Here you put oxygen, here you put oxygen. Break this, here you put oxygen, here you put oxygen. So first compound we are going to form from this one. So we get OH and here C double bond OH. Then second from this one. So here we write CHO, then CHO. And then one carbon is this. So one carbon is this. So we can write one carbon aldehyde, which is HCHO. Okay. So we get three products. So answer is going to be option number 1. ठीक है बेटे. अच्छा, one more thing here. What we can do? ठीक है. That's it. Nothing. You cannot do anything in this. This is going to be the answer. Okay. Now moving on to the next question. The major product of the following reaction is. So what happened over here? We have CH3, CH2, CH double bond CH2. So when you see this one H2O CO and rhodium catalyst. So what happens from this? We get CHO. We get CHO. ठीक है? We get CHO. So what we can do? What you are going to do? CH3, CH. Just do Markovnikov. Here you put CHO and here you write CH3. Or what you can do? CH3, CH2, 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 CHO. Okay. So if you see option number 3, that is going to be the correct answer. Yani across the double bond you have to put CHO. Okay, across the double bond you have to put CHO group. Let's discuss next type of problem which is based on physical properties. So the first question is, consider the following molecules and statements related to them. So first is this one. We have OH, C double bond O and OH. So here we have intramolecular hydrogen bonding. Now we have substituent on para position. See. So when we have para substituted, C double bond O OH, then we have intermolecular hydrogen bonding. It means hydrogen bonding is in between two molecules, right? Two molecules. So due to this molar mass increases, boiling point increases, it becomes less steam volatile or crystalline nature also increases. ठीक है? So now let's read statement. So statement 1, B is more likely to be crystalline than A. True, because we have intermolecular hydrogen bonding. Next, B has higher boiling point than A. Yes, true. Why? Because due to intermolecular hydrogen bonding, molar mass increases. Now, B dissolves more easily than A in water. Yes, true. Why? Because if we have the para form, then it can form hydrogen bonding with water molecules, right? It can form hydrogen bonding with water molecules. Understood or not? So that's why B is going to be more soluble than A in water. So option is going to be A, B, C, both, all are true statements. Okay. Now we are moving to the next type of question, which is based on the chemical properties of carbonyl compounds, not carboxylic acid. So generally in this we are going to discuss question which is based on nucleophilic addition reaction. And with respect with addition to that, you should know the functions of reagents. Functions of reagents. Okay. So let's do. So question number 1, are formed in the following sequence of reactions. So we have this double bond O, this, and here Cl. We have NaCl. So NaCl, so Cn minus Na positive. So nucleophile is going to be Cn minus bache. Nucleophile is going to be Cn minus. So Cn minus attacks onto this carbonyl carbon and electron of this bond shifts towards oxygen. So Cl, then we have O minus and here we write Cn. Then we have acetic acid, CH3COOH. So what is the role? Up now acetic acid hai, so what we can say that cyanide can hydrolyze. Ab dekho, two things are going to happen over here. What happened? First, here we write OH and then Cn is converted to the carboxylic acid. Now there is main thing, matlab there is a reason behind that. Why in the presence of acetic acid we are hydrolyzing cyanide? Because what happens if we have cyanide bond, so just break it in the presence of H2H plus, break it. So nitrogen delta negative and carbon delta positive. Why? Because electronegativity of nitrogen is more in comparison to electronegativity of carbon. So when we break 3 bond to put H, 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 and here write OH, OH, OH. Now 2 OH are unstable on one carbon, so rapid loss of water. So we get C double bond O OH plus NH3 बचे. ठीक है. अब now why I am writing carboxylic acid? Because only acetic acid is given, nothing is given कि H2O H plus है, so nothing is given. So it means simple acetic acid है, so we have to assume that this is the solution of acid. It is not acetic acid, it's a solution of acetic acid. Why? Because further reagent is ETOH and H plus, alcohol and H plus. So this is, if we form carboxylic acid, then we can form ester because this is the esterification reaction, right? So if we write here Cl, OH, this C double bond O OH. So in the presence of ETOH and concentrated H plus, so what we are going to do? Removal of water. So we write OH and H. So remove water. So we get ester. Here OH, this, and then C double bond O OET. ठीक है बेटे? ठीक है? Fine. Now we have 2 moles of MEMGBr and then hydrolysis. So MEMGBr, so CH3MGBr. So delta positive, delta negative, and here carbonyl carbon delta positive, oxygen delta negative, and OET is going to be the leaving group. So here we are going to do nucleophilic substitution addition elimination reaction, or simply we can say substitution reaction. So what happened? Methyl group attacks on this carbon and OET leaves. So when this happens, we get Cl, OH, this, then C double bond O, CH3. Clear? Now we have 1 mole of Grignard reagent, CH3MgBr. Now what happens? Again we have this group. So what we are going to do? CH3 attacks on this carbonyl carbon, electron of this bond shifts over here because now we do not have leaving group. No leaving group over here. And oxygen forms bond with MgBr. So we write Cl, OH, this, C, CH3, CH3, and O, MgBr. Now on hydrolysis. On hydrolysis, we have to break this bond. So delta negative, so here we put H and here we put OH. So we get Cl, OH, this, C, CH3, and then OH. Clear or not? Now let's compare the answer. So we have option number 2 as the correct answer. ठीक है बेटे? 2 as the correct answer. Okay. Now moving on to the next question. Assertion A: acetal and ketal is stable in basic medium. It is true. Why? Because acetal and ketal is unstable in acidic medium. So acetal, we have CH3, or we can write HCOCH3, right? OCH3, and then we write, let me write completely. So CH3, C double bond OH, so acetal. So what we are going to do? CH3OH in the presence of dry HCl. So first we write CH3, CHOH and OCH3, that is hemiacetal, and then we form CH3, CHOCH3 and OCH3. So this is acetal. ठीक है. अब now if we have ketal, तो ketal is formed from ketone. तो CH3, C double bond O, CH3. So on reaction with 2 CH3OH and dry HCl, we get CH3, CH3, OCH3 and OCH3. So this is unstable in acidic medium. Why? Because in acidic medium, this bond is going to break. Oxygen negative charge, carbon positive charge. So here we write H, here we write OH. This bond break, so here we write H, here we write OH. So we get CH3, CHOH and OH. Now two OH are unstable on one carbon. So we get aldehyde after loss of water. So it is unstable in acidic medium, but basic medium में doesn't happen, right? अब now questions, reason R says the high leaving tendency of alkoxide ion gives a stability to acetyl ketal in basic medium. No, ठीक है? So that is not true. That is not true. Basically, we have electronegativity difference, and we do not have, मतलब we do not have electrophilic center, right? We do not have more electrophilic center. That's why OH minus cannot attack on any carbon. So this gives stability to acetal and ketal in basic medium. So this statement is false. So we say assertion is true, but R is false. Okay. Now, moving on to next question. So we have naming reaction. So first is Hoffman bromamide degradation. So in this, what happened? We have RC double bond O NH2 group. Now in the presence of Br2 and OH minus, what happens? You are just going to remove this CO and we get RNH2. We get 1 degree amine. Okay? So A can be matched with third weighted. Now we have only two options with respect to the 1 and 3. Now let's do that one which is different. So let's take C. C is different now. So C, Canizero. So Canizero. So Canizero, aldehydes which do not have alpha hydrogen, they undergo Canizero reaction, and we require concentrated NaOH or concentrated KOH for that, right? So it means C can be matched with option number 1. So on the basis of that, we can say option 3 is the correct answer. There is no need to check. Otherwise, you should know Clemmensen reduction के लिए 4 and Reamer-Teamer, that is 6. Matching में you can use this thing. ठीक है? चलो, let's do next question. So we have discussed similar type of question in hydrocarbons also. So question says we have this one OH and double bond O can be easily reduced to using ZnHgHCl. But when you do Clemmensen reduction, so what happened here? OH is also converted to Cl because OH is acid sensitive group. OH is what? Acid sensitive group. So first OH is converted to OH2 positive, then OH2 leaves and we have Cl in place of OH. Okay? And next part is that only this keto group, it is reduced to alkane part. Okay? So we get this one. We do not get this. So that is false. ZnHg in presence of HCl is used to reduce carbonyl group to CH2 group. Yes, this is true. So assertion is false, but R is true. So we can say option 1 is going to be the correct answer. Okay. Now let's do next question. We have cyclohexylamine when treated with nitrous acid. Cyclohexylamine treated with nitrous acid. It means HNO2. Up now HNO2 is formed by the reaction of NaNO2 plus HCl because we have amine now. So just think it like that. NaNO2 plus HCl. in 0 to 5 degrees Celsius. So these conditions are not given, but you have to assume this, right? So we get N2 plus Cl minus. So this is not aromatic, right? This is not aromatic. So what happens after reaction with HNO2 na, it is converted to OH, right? It means if we have RNH2, so in the presence of HNO2, 0 to 5 degrees Celsius, we get ROH directly. We are going to remove N2 obviously. Okay? But we write ROH. But if we have ArNH2 and this is 1 degree, so we get ArN2 plus Cl minus. That is benzene diazonium chloride. So we get this. If we have aromatic, okay? So it means this is going to be P. Up now I'm treating P with PCC. So this is P. So I'm treating P with PCC. What is PCC? Pyridinium chlorochromate. And what is the use of this? This is the mild oxidizing agent. Mild oxidizing agent. So 1 degree alcohol is converted to aldehyde, and 2 degree alcohol is converted to ketone. Okay, 2 degree alcohol is converted to ketone. So we get double bond O. Okay, now next part. When Q is heated with dilute NaOH, we get R. We get R. So we have ketone. Now if it is heated with dilute NaOH, so it means we have to perform aldol because alpha hydrogen is there. Alpha hydrogen, they are present. So first what we are going to do? In the presence of NaOH minus, so just remove hydrogen. Okay, bete? So we write double bond O and negative. Condensation, aldol condensation, it means 2 groups are required. So what we are going to do? Now this negative charge is going to attack on this carbon because we both are ketones. So ketone can attack on ketone, then electron of this bond shifts to oxygen. So by doing so, we get double bond O, and here we write O minus, then we have 6 membered ring. Clear? Then after that, because this OH minus abstract H plus, so it forms water. So in the presence of water, what do we write? We write double bond O, and here we write OH. Okay? Heating is given. Do we have heating? Heated, yeah, heating is given. So it means we have to do condensation. Condensation means removal of water. So we get alpha beta unsaturated carbonyl compound. Alpha beta unsaturated carbonyl compound. So see, this is alpha carbon, this is beta. So now alpha and beta pe we have to put double bond. So OH is removed, hydrogen is removed from here. So removal of water happens, and the product is going to be double bond O. Here we put double bond and this. Clear? So now let us match with the correct option. So option B is going to be the correct answer. Okay? Now let's do next question. Oh, it's a big question, huh? The structure of major product A, B, C in the following reaction sequence are. So let me write everything. So we have, okay, that is double bond O and H. Okay, we have NaSO3 and dilute HCl. So NaHSO3, so Na plus and then HSO3 minus. So HSO3 minus is going to be as double bond O, OH and O minus. Okay, this is HSO3 minus. So O minus attacks over here and electron of this bond shifts over here. Okay, so we get O minus, here we write H, and O as double bond O, OH. Okay, now then we have HCl, dilute HCl is there. So in presence of dilute HCl, what happens? Here we write H. Here we write H. So we get OH, H, O, S double bond O, OH. Okay. Now next part. We have NaCN and H2O. So NaCN and H2O. It means NaCN in the presence of water gives Cn minus na as a nucleophile. A nucleophile can attack on this carbon. Why? Because this is going to be the leaving group, a good leaving group, which is resonance stabilized. देखो, we have resonance over here, है ना? So resonance stabilized is a good leaving group. So what we can do, Cn minus can attack on this carbon and this leave. So we get this OH, H and C. ठीक है जी, fine. So we get A and we have to find out A, B and C. So this is A. Up now we have LiLH4. LiLH4, it reduces, right, cyanide to amines. Cyanide to amines. So we write OH, H, CH2, NH2. So this is B. Now the third one, A on reaction with HCl and H2O. So HCl and H2O, we have to do hydrolysis. So this is C na, C triple bond N. So we have to do hydrolysis. So hydrolysis of cyanide gives carboxylic acid. Okay, bache. Plus ammonia. So that is C. Now just try to find out the correct option. So A is going to be cyanide. Then we have CH2, NH2. So if we look for the correct option, so that is option number 4. ठीक है. चलिए. Now let's do next question. Next question says कि we have bimole, so double bond H, and we have this OH. Now X mole of MEMGBr H3O positive gives MEOH HOH. ठीक है. So question says the ratio of X and Y on completion of the above reaction is. So see, this Grignard reagent na, it is base. So the first function is to abstract proton. It is going to act as base, and in the second one it can show nucleophilic addition reaction. So if we see acidic hydrogen, so here we have acidic hydrogen. So 1 mole of MEMGBr, ठीक है बेटे, Me delta negative, magnesium delta positive takes hydrogen, then electron of this one shifts to oxygen and oxygen forms bond with MgBr. And another mole MEMGBr, delta negative, attacks over here, electron of this one shifts to oxygen and then oxygen forms bond with MgBr. So we have HOMGBr, MEOMGBr plus CH4, methyl plus hydrogen CH4. Now hydrolysis. So when we do hydrolysis, we get exactly this product. Okay, bete, on hydrolysis we get exactly this product. So ratio of X and Y on complete. So X 2 mole. We are going to use 2 mole of this per mole of Y. So ratio of X plus Y, X upon Y is equal to 2 upon 1, which is equal to 2. So answer is 2. Okay, answer is going to be 2. Now let's do next question. Okay, question says ki like we have this Me C double bond O, then 1 2 3 4 double bond O and CH3, OET minus and then heat, and we have A as the major product. So how to solve this? So see, OET minus, in the presence of heat, its main function is to abstract hydrogen. Abstract alpha hydrogen. So dekho, see, just try to identify alpha hydrogen. We have alpha hydrogen over here. We have alpha hydrogen over here. And we have same groups, right? So what we are going to do? We are going to do intramolecular reaction, or intramolecular reaction we are going to do. ठीक है? So just remove alpha hydrogen. So we have two situations, na? Me double bond O, 1, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 double bond O and CH2H. So if I remove hydrogen from here, so we get CH2 minus over here. So this is going to be a nucleophile, and the nucleophile attacks on this carbonyl carbon and electron of this bond shifts over here. ठीक है बेटे? So by doing so, we get 1, 2, 3, 4, 5, 6, 7. So we form 7-membered ring. So 7-membered ring we cannot form, right? We cannot form 7-membered ring. Now we have another possibility. What is other possibility? We have hydrogen over here. So let's remove hydrogen from here. So negative charge comes over here and we do this. By doing so, we get 1, 2, 3, 4, 5. 5-membered ring. So 5-membered ring we can form. So let's form 5-membered ring. So this is 1 number carbon. Now 1 number carbon is bonded to this C double bond O CH3. So 1 number carbon is this. So it is bonded to double bond O CH3. Then this is second number, this is third number, this is fourth number, this is fifth number. Now fifth number carbon is this O minus and CH3. So here we write O minus and CH3. Okay. Now what happens? Hydrogen abstraction, right? So OET minus abstract hydrogen to form ETOH. So in the presence of this, we add H plus. So we write double bond O CH3 and OH and CH3. Now we have heating. So this is alpha carbon, this is beta. So what we are going to do? Just do elimination of water. So we get alpha beta unsaturated carbonyl compound like aldol. So we can say this is going to be intramolecular aldol. Okay, but intramolecular, for intramolecular aldol we should be having NaOH dilute, KOH, but this is this similar thing, right? This is going to be the similar thing. Okay, bete. Now if we check which is the correct option, option 3 is going to be the correct answer. Now let's do next question. So next question is this. Okay. So OC2H5, let's do one by one. So first we have OC2H5, then CH2, C double bond OH. We have NH3 in the presence of HCl, because NH3 in the presence of HCl gives ammonium chloride. So what we will do? Ammonia and ammonia derivatives. With ammonia and ammonium derivatives, we have to remove water. How do we remove water? So we write H2NH. ठीक है बेटे? H2NH. So what we can do? Just remove water. ठीक है? So after removal of water, we write OC2H5. ठीक है बेटे? Then CH2 CH double bond NH. Clear? Double bond NH. Then we have KCN. Then we have KCN. KCN. So KCN, so CN minus. So CN minus, this is delta negative, this is delta positive. So CN minus attacks on this carbon and electron of this bond shifts to nitrogen. So we write OC2H5, then CH2, CHCN and NH negative. Clear? Understood? Now we have H2SO4 and H plus. So H2SO4 and H plus, it has two functions. Here we write one H plus. Here we are going to write one H plus. Or CN is converted to COOH. So we write OC2H5, CH2, CHCOOH, and here we write NH2. Okay. So we have this. So this is what? This is amino acid. है ना, alpha amino acid, alpha amino acid. Now next, so this is A, this is A. Now we have concentrated HNO3 and H2SO4 two equivalent. Concentrated HNO3 and concentrated H2SO4 two equivalent. So this shows electrophilic aromatic substitution. So this is electron releasing group. So we are going to do electrophilic aromatic substitution with respect to this. And for that, suitable sites are ortho position. Why? Because para position is occupied. So we have ortho position free. Ortho is free. So what do we get? We get something like that. OC2H5. Here we write NO2. Here we write NO2. Then CH2, CH, COH and NH2. Clear? Now next, we have acetic anhydride. Acetic anhydride. Okay, बच्चे. So let me rewrite this. एक मिनट. Let me rewrite this. ठीक है. So अब now what happens? Acetic anhydride CH3 C double bond O and C double bond O CH3. So here what happens? This NH2 can attack on this carbonyl carbon and this leaves, because this is the leaving group, and this reaction is known as the protection of amino group. Protection of amino group. Okay, or we can say acylation of amino group. So by doing so, what do we get? We get OC2H5, बच्चे, NO2, NO2, then CH2, CH, COOH, and here we write NH, C double bond O, CH3. Clear? Next, we have ETOH and heat. Again, esterification reaction, right? Esterification. So ETOH and heat. So what do we get? This carboxylic acid is converted to ester. We have to form ester over here. So we write O, C2H5, NO2, NO2, CH2, CH, C double bond O, OET. We have to remove water na, so OH and H. So OET, and then we write NH, C double bond O, CH. Clear? Okay, bete. Now let me rewrite this. So CH, and here we have NH, C double bond O, CH3. ठीक है? Let me form benzene ring. Okay, next, H2PDC carbon, palladium carbon. So what is the function of this? What is the function of this? It reduces NO2 group to NH2 group. H2PDC. So it reduces NO2 to NH2. ठीक है? NO2 to NH2. So let me rewrite. So we get OC2H5, NH2, NH2, then CH2, CH, C double bond O, C2H5, NH, C double bond O, CH3. ठीक है? Next step, HNO2 and then NaI. So first we are going to form benzene diazonium chloride. So HNO2 say we are going to form, because this is 1 degree aromatic amine. So we form benzene diazonium chloride. So we write OC2H5 N2 plus, N2 plus, and here we write CH2, CH, C double bond O, OC2H5 and NH, C double bond O, CH3. Then NaI. So I minus attacks over here and N2 leaves. Similarly, I minus attacks over here and N2 leaves. So we have final product OC2H5, iodine, iodine, CH2, CH, C double bond O, C2H5 and NH, C double bond O, CH3. Fine. Now Question says we have to find out the value of X. So X is CXH19NO4I2. So let me compare. What is this? CXH19NO4I2. NO4I2. So let me count number of carbon atoms. So we have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have C15. We have C15. Hydrogen, let me count hydrogen. So hydrogen are going to be 5, 6, 7, 8, 9, 10, 10, 5, 15, 16, 17, 18 and 19. Fine, hydrogen 19. We have one nitrogen, okay. Oxygen we have 4, 1, 2, 3, 4 and we have 2 iodine. So it means X ka value is going to be 15. So we have to report the answer in terms of 15. Answer is 15. Okay. Now let's do next question. So next question is this. The major product Y in the following reaction is. So we have this CH3, CH, CH3, then C triple bond CH. We have Kucherov reaction, right? HgSO4, H2SO4 and water. So it means we have to do hydration of alkynes. So for hydration of alkynes, we have to follow Markovnikov rule, right? We have to follow Markovnikov rule. So from this we get CH3, CH, CH3. With this carbon we write OH, then double bond CH2, which is tautomerized to give CH3, C, CH3, C double bond O, or let me rewrite. This is CH2, which on tautomerize gives CH3, CH, CH3, then C double bond O, CH3. So we get ketone. Okay, we get ketone. Up now we have Grignard reagent. So if we have ketone, then in the presence of Grignard reagent is C2H5MgBr. So I have already discussed the mechanism in the in above reactions, above questions. So what we are going to do over here. So suppose C2H5 MgBr. Okay. So what we are going to do? We are going to form alcohol. So C2H5 reacts, so attacks on to this carbonyl carbon and we get CH3, CH3, then COH, C2H5 and this is CH3. So we get 3 degree alcohol. Okay. Up now we have concentrated H2SO4 and heat. So it means we have to do elimination reaction. So in the first step, what will happen? What is going wrong? So in the first step, what will happen? CH3, CH, CH3, then C, C2H5, CH3, and here we write OH2 positive. So OH2 leaves. So we get CH3, CH, CH3, then C positive, C2H5 and CH3. So this is 3 degree carbocation. है ना? This is 3 degree carbocation. So what we are going to do? We are going to form Sedgwick product as the major product. So what is the Sedgwick product? So we have to remove this hydrogen in order to form the Sedgwick product. So CH3, C, CH3, double bond C, C2H5 and here CH3. So we have to form Sedgwick product. ठीक है? So for Sedgwick product we have to remove this hydrogen. Now let's find out the correct answer. So option number 4 is going to be the correct answer. Okay. Now next question. Consider the following reaction. So we have A and first is CH3MgBr and second we have HCO positive. So it gives B. Now in the presence of copper 573 Kelvin we get 2 methyl 2 butene. So see, copper 573 Kelvin, it is mild oxidizing agent and it removes hydrogen H2. It removes hydrogen. Just for example, if we have a CH3, CH2 and OH. So what we are going to do, just remove hydrogen and we get CH3 C double bond OH. So 1 degree alcohol is oxidized to aldehyde. Okay? But here we get alkene. So alkene is formed from 3 degree alcohol, because if 3 degree alcohol reacts with copper 573 Kelvin or silver 573 Kelvin, we get alkene after the removal of water. Okay, so it means if we have 2-methyl 2-butene, so 1 2, so 2-methyl 2-butene, 2-methyl butene. So if this is formed, it means we have 3 degree alcohol. So 3 degree alcohol, if I want to form 3 degree alcohol, so this is going to be CH3, CH3, this is OH, and we write CH2 and CH3. Okay? So for elimination, we have to remove this hydrogen, right? So this beta hydrogen is removed, and then we get alkene. That is after copper 573 Kelvin. So this is B. Now CH3 MgBr and HCO positive. So we get 3 degree alcohol now. So 3 degree alcohol is formed from ketone if we react this with Grignard reagent. So we have CH3 MgBr. Okay, bete. So now what we are going to do, there is a trick. So just remove this part because this is from the Grignard reagent. So the ketone is going to be CH3 C double bond O CH2 CH3. So when this ketone reacts with Grignard reagent and after hydrolysis, we get 3 degree alcohol, this 3 degree alcohol. Okay. Now we have to find out mass percentage of carbon in A. So total mass of carbon, we have 4 carbon atoms, 1, 2, 3, 4. So 12 into 4 divided by total mass, 12 into 4, 1 into 16 because 1 oxygen. And we have how many hydrogen? 3, 4, 5, 6, 7, 8 plus 8 into 1. So into 100, right? Into 100. So on solving this, we get 48 upon, this is 48 plus 16 plus 8 into 100. Okay? So on solving this, we get 66.6 percentage, which you can write as 67 percentage. Clear? 67 percentage. Clear? That's it. Now next question, CH3 CH2C CH3 CH2 COH pH and CH3 cannot be prepared by. So this is 3 degree alcohol now. So we can prepare 3 degree alcohol from ketone and Grignard reagent. Ketone and Grignard reagent. So suppose we have ketone R dash C double bond O R double dash. So when we react with R MgX, so we get R dash COH R double dash and R from Grignard reagent. Okay. So just we have to apply this trick. So first is CH3 CH2 CO CH3. A is CH3 CH2 C double bond O CH3, and we have phenyl MgX. So what we are going to do, CH3 CH2 COH, then CH3 and pH. So we get the same product, CH3 ethyl and phenyl, CH3 ethyl and phenyl. Okay. Now check second one, phenyl COCH2, phenyl for second one, phenyl C double bond O CH2 CH3 plus CH3 MgX. Again what do we get? Phenyl COH CH2 CH3, and here we write CH3 from the Grignard reagent. Okay. Now let's check third one, PHCOCH3 PHCOCH3 plus CH3 CH2 MgX. So how do we write? PHCOH, then CH2 CH3 from Grignard reagent, and then CH3. Now last option is fourth, that is going to be incorrect. Answer is this, but let me write down the correct product. So at C double bond OH, then we have phenyl CH CH3, phenyl CH CH3 and then CH2NPX, है ना? ठीक है. So from that one we get HCOH H, then CH2 CH3, and that is phenyl. Okay, so we get 1 degree alcohol from here. Clear? That's it. So answer is going to be fourth one. Next question. Identify A in the following reaction sequence. Oh, so this is the product. So we have to do reaction from backwards. Okay. So see, we have this. This is formed after ozonolysis, है ना? After ozonolysis, O3 and Zn H2O. So what we are going to do? Just remove oxygen and join these two carbon, right? Join these two carbon and we get alkene. This is a trick. So we have CH double bond C, which is bonded to CH3. Then we have CH, not CH, C, and which is bonded to 2 methyl groups. Okay, so this is B. This is B. So let me write this. Okay, so this is B. Now this B is formed from A1, but first step is concentrated H2SO4. So concentrated H2SO4 means dehydration. Dehydration. It means we must remove H2O, and for that OH should be present. OH should be present. So if OH should be present, so what we can say? We can write CH double bond C, CH3, then this is C, CH3, CH3, and this is OH. So this is a 3 degree alcohol, right or wrong? This is 3 degree alcohol, this part. Now this 3 degree alcohol is formed from Grignard reagent, right? From Grignard reagent. CH3 MgBr and H2O. MgBr and H2OH plus. So 3 degree alcohol is formed from ketone. From ketone, it means we have to write this CH double bond C, CH3, then C double bond O, CH3. Because one of the CH3 is from the Grignard reagent, right? So we have this, this should be the reactant A. So now let's find out which one is this reactant. So option 2 is going to be the correct answer. Clear? Understood? That's it. Now let's do next question. So next question is this. We have A, and A on reaction with this we get B. So let's do step by step. So we have CH, CH3, C triple bond N. Okay, and we have C2H5 MgBr. We do not have acid. So what is the role of Grignard reagent? Nucleophilic addition. So this is delta negative, delta positive. Carbon delta positive, nitrogen delta negative. So C2H5 forms bond with the carbon. Electron of this bond shifts to nitrogen, and nitrogen forms bond with MgBr. Okay, bete. So we write this. CH, CH3, then C, C2H5, double bond N, MgBr. ठीक है. अब now we have to do hydrolysis. We have to do hydrolysis. एक मिनट बच्चे. So we have to do hydrolysis. So after hydrolysis, ठीक है. So एक मिनट. ठीक है. So we have to do hydrolysis. So after hydrolysis, H2O positive, what we are going to do? We have to dissociate this bond, carbon nitrogen bond. So nitrogen is more electronegative, carbon delta positive, तो here we write OH and OH, nitrogen के साथ we write HH. So with this we are going to write CH, CH3, then C, C2H5. Now 2 OH are unstable on one carbon, then there is a loss of water, so we write C double bond O. ठीक है? So this is going to be A. Now what we are going to do afterwards, CH3 MgBr and then H2O. Then we have CH3 MgBr and H2O. So CH3 is going to form bond with this carbon and this oxygen is converted to OH. Okay, so from this we have CH, CH3, COH, C2H5 and CH3. Okay ji. Now the question says number of chiral centers present in B is, so this is my B. So how many number of chiral centers? So see, this is chiral center. This carbon is bonded to 4 different groups. Then this is chiral center, 4 different groups. Then chiral center is going to be 1 is this, 2 is this, 3rd is this and 4th is this. These 4 carbons, they are bonded to 4 different groups. Check in this one. CH2, CH, CH3. CH2, CH2. Different group. Right? Different group. Then one is going to be the hydrogen. Another one is CH, CH3. Matlab complete group. Complete this group. Okay. That's it. Now. So we have 4. So answer is going to be 4. Now, next question. The major product obtained in the following conversion is. So we have Br to 1 equivalent and we have MEOH. MEOH. So Br to 1 equivalent, so we will form bromonium ion, है ना? Double bond के across double bond, we will form bromonium ion. So we write Br positive. ठीक है? अब now what will happen? Now what will happen? ठीक है? Intramolecular attack is not going to happen. So here we have OMe minus. Why intramolecular attack cannot happen? Because we have oxygen ka lone pair, but that is involved in delocalization, right? So that's why it's not solely available for attack. So that's why we do not have intramolecular attack. So here OMe minus is there. So OMe minus attacks on this carbon and electron of this bond shifts to Br. ठीक है? Up now we have two conditions na, because if this bond is formed, then we will have the carbocation formation over here and this is going to be the 2 degree carbocation. ठीक है? अब now if I dissociate this bond, then carbocation is formed over here which is nearer to electron withdrawing group. So here it is less stable. Okay, so that's why we have to do blue wala attack, and by doing blue attack we get O double bond O CH3 and here double bond O Br, then CH2 CH3 and OMe. ठीक है? So let's find out the correct option. So option 1 is going to be the correct answer. ठीक है? Now let's do next question. The next question, NaBH4 MEOH 25 degrees Celsius. So how to solve this? NaBH4. So NaBH4 we have double bond O. अच्छा, NaBH4, so it reduces ketone to 2 degree alcohol, NaBH4. So we get Br. Ab now what we can do? Ab now intramolecular attack can happen. Oxygen can attack on this carbon and Br leaves because Br is leaving group. Okay, bete. So we get this situation. Obviously we get cyclic ring and that is going to be OH positive and here we write this. Okay bachche. अब we have OCH3 minus from MEOH. So it takes this hydrogen and electron of this bond shifts to oxygen. So we have this situation. Okay. Clear? So we can form this. So option 4 is going to be the correct answer. Intramolecular attack can happen. Okay, bete. Clear? Now if you take OCH3 minus or what we can say minus H plus. Okay, that's it. Okay, that's it. Because now OMe minus cannot attack over here. So this kind of attack is going to happen. Okay, option 4 is going to be the correct answer. Okay, now next. The major product C of the following reaction sequence. So we have CH2 double bond CH and this is the C double bond OH. So NaBH4. NaBH4 reduces aldehyde to 1 degree alcohol. So we get CH2 double bond CH and CH2OH. Then we have SOCl2. So SOCl2 converts ROH to RCl. So we write CH2 double bond CH and CH2Cl. So this is A. Then we have anhydrous-AlCl3 benzene reaction in the presence of anhydrous-AlCl3. So this is Friedel-Crafts alkylation. So for alkylation, what happened? What happened? CH2 double bond CH and CH2Cl. So Cl leaves. So we get CH2 double bond CH and CH2 positive. And Cl minus combines with AlCl3 to form AlCl4 minus. Because AlCl3 is Lewis acid, so it accepts electron pair from the Cl minus. ठीक है, अब now we have to do electrophilic aromatic substitution. So by doing so we get benzene ring and then CH2 CH double bond CH2. ठीक है, so this is B. This is B. Now let's write C. So beta this is B. Ab now what we are going to do? We have DBr. DBr. So it's similar to HBr. We have to do Marconi curve. So first step we have to form carbocation. So electron of this bond attacks on this and Br minus leaves. And we get CH2 CH positive and here we write CH2D. Now what happens? This is 2 degree carbocation and if we do hydride shift, then we get benzylic carbocation which is more stable. So here we write CH positive, CH2, CH2D. Right? Here we get benzylic carbocation which is more stable. Right? This is benzylic position. Now next we have Br minus. So Br minus attacks on this carbocation to give this product CHBr CH2 CH2D. Okay, now let's find out the correct answer. This is C. So C is going to be CHBr CH2 CH2D. So option 1 is the correct answer. Clear? Option 1 is the correct answer. Now next question. The increasing order of the reactivity of following with LiLH4 is. So how to do this? This is also on the basis of reaction mechanism concept. See, in LiLH4 we have Li plus and AlH4 minus. AlH4 minus further gives AlHC and H minus. It means it gives hydride H minus. H minus is going to be nucleophile. So we have to check in which case nucleophile addition is faster. So for nucleophilic addition, we should be having less nucleophilic carbonyl carbon. We should be having less nucleophilic carbonyl carbon. So see, this is NH2, this is OH3, this is Cl and this is OCOCH3. So we are going to attack H minus over here. Okay? Now, see, Cl minus, it shows minus I effect. OCH3 shows plus R effect because it forms resonating structure. NH2 shows plus R effect. Even O shows plus R effect. But here what happens? Oxygen is also bonded to this group. So oxygen lone pair can go to right hand side also. ठीक है, so the fastest rate is going to be in C. Now we have only two options, 2 and 3. After C we have to find out, अब now देखो there is no other, we have either option number 2 or 3 as the correct. So C के बाद it is D, सही बात है, because oxygen lone pair is not solely available for one site, it is for two sites. ठीक है, so we have D, then we have OCH2 and NH2. अब now oxygen is more electronegative atom, so it has less tendency to give its lone pair to carbonyl carbon in comparison to NH2, right? So then we have B and then E. ठीक है, तो option 3 is going to be correct answer. Why? How do we compare B and A? How do we compare B and A? Oxygen being more electronegative has less tendency to give lone pair to C double bond. Okay, that's why we have option number 3 as the correct answer. Let's do next question. The major product of the following reaction. So it's simple, double bond O, NaBH4 and we can say ETOH. ठीक है, so what we are going to do, just OH. ठीक है, तो in NaBH4 के presence में we can have solvent as ethanol, it is possible. तो option 2 is the correct answer. Okay, next question. We have this, the major product of the following reactions. So we have dibyl H, diisobutyl aluminium hydride. What is the role of this reagent? It converts cyanide to CHO. Dibyl H converts cyanide to CHO and esters to CHO, right? So it means this is ester, this is ester. So here we write CH2. Now this double bond O H, ठीक है, and here we write OH, ठीक है बेटे. So the point is esters are reduced to CHO, so we get CHO, OH and CH2. So here we write CH2 and this is CHO, this is also CH2 and CH2. Just this question is based on the function of reagent. Function of reagent, nothing else. Okay, now let's do next question. The major product of the following reaction is, so we have this double bond O, OET and we have C triple bond N. So in the presence of nickel H2, what we are going to do, cyanide is reduced to amines. So we write CH2 NH2. Now dibyl H, esters are converted to aldehyde. So we get CHO, or we can write C double bond OH plus ETOH and then CH2 NH2. Up now we have NH2, so intramolecular attack happens. Intramolecular, तो intramolecular में just remove oxygen and H2. ठीक है, so we are going to do intramolecular attack and we have to remove water. So we get CH double bond N, CH2 and this. Now comparing this, we can have option 4 as the correct answer. Now next question, the major product of the following reactions. So we have RC triple bond N and this is aluminium isobutyl, diisobutyl. So this is dibyl H, nothing, it is dibyl H, diisobutyl aluminium hydride, right? And then we have water, so we have RCHO, ठीक है, RCHO. So cyanides, they are converted to RCHO. So first cyanides, right? they are converted to RCH double bond NH. Then in presence of water, we are going to dissociate this. So HH. Why? Because delta negative. Delta positive. So with this carbon OH in OH. So we get RCHOH and OH. Two OH are unstable on one carbon. So rapid loss of water. So RC double bond OH. Understood? So option is third. Now, next question. We have this ketone, right? This is ketone, alkene, then CH2, C double bond O, OCH3. So NaBH4 in presence of ETOH, NaBH4 function is to reduce carbonyl to alcohol. ठीक है? Carbonyl to alcohol. It can reduce imines also. Imines to amines. It can reduce. So in place of OH, what do we get? We get, in place of double bond O, we get OH. So CH2, C double bond O and OH. So option 4 is the correct answer. Clear? Now, next question, we have this and NaBH4. So see, this is imine. This is imine. CH3 and double bond C H then CH2 like this. Further, and this is ketone. So this part is imine bache and this part is ketone. So NaBH4 reduces imine to amines and ketone to alcohol. So we get CH3 NH CH2 then CH2 this double bond and OH and this. ठीक है बेटे? Clear? So on the basis of that, we have option number 4 as the correct answer. Completely based on the functions of reagent, nothing else. So reagents are very important in organic chemistry. ठीक है? And also in aldehydes, ketones and carboxylic. Okay. Now see, we have aldehyde and ketone. Here we have aldehyde and here we have ketone. Dilute NaOH. It means we have to do aldol condensation. Aldol condensation. So in aldol condensation, we have two steps. Na? So first, generation of carbon ion. So, and second is nucleophilic attack. So nucleophilic attack is easier in aldehyde. Easier in aldehyde. ठीक है? Because of one electron releasing group. So this carbon is more, or we can say less nucleophilic. Less nucleophilic. So what we are going to do, if we have this C double bond O CH3. So this is alpha carbon. So in the presence of base, we have to abstract this hydrogen. So we get C double bond O and CH2 minus. Up now this can react with aldehyde. So CH2 minus attacks on this carbon, an electron of this bond shifts over here. So we get C double bond O, CH2, CO minus H and CH3. Then in presence of water, because this OH minus takes H plus, it forms water. So what do we get? We get C double bond O, CH2, CHOH and CH3. Okay? So that is going to be the major product. Heating is not there, so it means there is no need to remove water. There is no need to remove water. So on the basis of that, what do we get? What is the correct answer? Option 3 is the correct answer. Clear? That's it. Now next, the major product obtained in the following reaction. So here we have aldehyde, here we have ketone. Again we have to do aldol, but that is going to be intramolecular aldol. Intramolecular aldol. So see, what happens? Here we have C double bond H. This is CH3 double bond O and here CH3. So see, we have two alpha hydrogen. One hydrogen is this alpha hydrogen and another alpha hydrogen is this. ठीक है? So if I remove this hydrogen, so we get CH2 minus over here, and then this CH2 minus attacks on this carbonyl carbon, and electron of this one shifts over here. By doing so, we get 1 2 3 4 5 6 7 7 membered ring, which is not possible, right? 7 membered ring, so we cannot form 7 membered ring. So let me write again. So we have C double bond OH, then we have CH3, CH2, 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 then C double bond O, CH2. So now what we are going to do, I am going to remove hydrogen from here. Okay, I am going to remove hydrogen from here. Okay, so negative charge. Now let's do attack. So 1, 2, 3, 4, 5. So we have 5 membered ring formation. So if this is the first carbon, so this is bonded to double bond O, CH3. Second, third, fourth carbon is bonded to CH3, and fifth carbon pe we write OH. I am writing directly OH. And then heating is there. So it means this is alpha and beta. So we have to form on heating. On heating, we have to form double bond over here. Okay? So after heating, we have to form double bond in between alpha and beta. Okay? So this is the answer. Now let's compare this answer. So option 2 is the correct answer. Yeah, option 2 is the correct answer. Now, next question. So next question is based on same thing, right? We have to do aldol. We have to do aldol. So first we have to form aldol product, and then we have to form aldol condensation product. Okay, condensation product. We have HCO positive, it means we have to do dehydration, है ना? In this step we have to do dehydration or removal. So what we are going to do, so we have to remove alpha hydrogen from here. Alpha hydrogen, just remove it from here. So we get CH2 minus, then double bond CH3, then this double bond O and H. Now then this CH2 attacks on this carbonyl carbon, and electron of this one shifts over here, right? Okay, so let me, okay, so CH2 minus attacks on this, and electron of this one shifts over here. So we will have 1 2 3 4 5 6. We will have 6 membered ring. So let's form 6 membered ring. So on one carbon we write OH. On this is 1, this is 2, this is 3. On fourth we have 2 methyl group. Fifth we have double bond, and this 6 is CH2. ठीक है बेटे? Okay, this is CH2. This is alpha and this is beta. Now on heating, we have to, this is alpha and this is beta, so we have to remove this. And on removal of water, what do we get? We get this double bond and this. ठीक है, एक मिनट. This is going to be the final product, that is B. Yeah, this is B. Okay, so what is the correct answer? Correct answer is option number B. B or 1. This is alpha and this is beta, है ना? This is alpha, this is beta, this is gamma. So beta gamma no. So the correct option is option number 1. Okay, clear? That's it. Okay, see, this is alpha and this is beta. Now next question, we have CH2 CH2 CHO and CH2 CH2 CHO. 2 aldehyde, we have NaOH, then C2H5OH in water, and then heat. ठीक है, water and heat. So we have to perform aldol. There is no other thing. We have to do aldol. ठीक है बच्चे? NaOH, C2H5OH, water, and then heat. ठीक है? So on doing aldol, we get first as the answer. But the point is that if here concentrated NaOH is given, now it should be given. Then we can do Canny 0 and we can have option number 4 as the answer. Right? If we have Canny 0, so we have to do this thing. And if we want to do aldol, so we have this thing. So nothing is clear in this step. What should we do? Right? So we have to form 7-membered ring. Nothing is going to happen. So let me write this. So here we do not have situation now, so we have to form. Okay, so this is C double bond OH, and here we write CH2, CH2 and C double bond OH. So what we are going to do, I'm telling you the trick. So let's write this, then CH2, CH2, now this carbon ke sath CHOH. Okay, this is alpha hydrogen, so remove hydrogen, remove one hydrogen. So one hydrogen and join with this. So we get CH, एक मिनट, CHOH, then we write CH, this is going to be C double bond OH, this is CH2 and this is going to be. Okay, now this is alpha, this is beta, and after heating what do we get? CH2, CH2, this is CH2, CH2, CH, or let me write CH2, CH2, CH double bond CH, this is going to be CHO, then we have CH2 in this. So 1, 2, 3, 4, 6, 7, 100. If you want to do aldol, okay? If I want to do aldol, then that is going to be the answer. Okay, now next question. So again in this we have to go from backwards, right? We have to go from backwards. So question says, in the following reaction A is, so see, this is the final product and this is formed from NaOH aqueous and heat. NaOH aqueous and heat. Acha, in the above question, we have NaOH and water is there, na? So that's why we can do aldol. Okay, because water is given. So that's why we have to do aldol. Okay. Next, NaOH aqueous and this. So retroaldol. Here we have to do retroaldol. It means from products we write reactants. So see, what we need to do, just break this. Here already carbonyl is present. Carbonyl is present. Here write oxygen because here carbonyl is not present. Carbonyl not present. ठीक है बेटे? So here what we are going to write? 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon, 6 carbon. So we have 6 carbon. So C double bond OH, this is 6 1. Then 5 CH2, 4 CH2, 3 CH2, 2 CH2 and then 1 C double bond OH. ठीक है बेटे? So this is how we can form aldehyde or carbonyl. So next CH3, 2CH or O3. O3 and dimethyl sulfide. So it means that is reductive ozonolysis. Reductive ozonolysis. And ozonolysis is from alkene. So what we are going to do? We are going to join these carbon. Okay. Join 1 and 6 carbon by double bond. So it means 6-membered ring and 1 double bond. Then we have, this is formed. Cyclohexene is formed from alcoholic KOH. Alcoholic KOH role is dehydrohalogenation. Dehydrohalogenation. So it means we should be having Br and this is alpha carbon and on beta carbon we have hydrogen. So from beta carbon we have to remove hydrogen. From beta carbon remove hydrogen and from alpha carbon remove Br. ठीक है? Now this is formed from Br2H. Br2H means free radical reaction. Free radical. Okay, so this must be cyclohexene because free radical is formed over here, and if we do Br2H nu, so we get this product. Okay, so it means A is cyclohexane, and option 1 is the correct answer. Okay, now next question, 50% NaOH and H3O positive. So 50% NaOH, it means it is concentrated NaOH, and then H3O positive. So this is Cannizzaro reaction. Cannizzaro reaction. So how to find out the product? So we have this CHO and we have HC double bond OH. So in this Cannizzaro, the smaller one is converted to carboxylic acid salt, and bigger one is converted to alcohol. That's a trick. Or carbonyl compound on which nucleophilic addition is faster is converted to carboxylic acid salt. ठीक है? So see, in this nucleophilic addition is faster, right? Why? Because this carbon is more electrophilic. This carbon takes electron from benzene ring, but in this we do not have any electron releasing group. So here what do we get? This one is converted to alcohol and another one is converted to carboxylic acid salt. We have one carbon, so we form one carbon carboxylic acid salt. Then in the presence of H3O positive, we get HC double bond OH. Okay. Now on the basis of that, what do we get? Answer is going to be option number 3. Okay, is it clear? Now next question, HCHO and NaOH. Okay, HCHO and NaOH. अब now देखो, here concentrated NaOH is not given ना, concentrated NaOH is not given, but if you see, this is C double bond H and this is OCH3, electron releasing group, and we have HC double bond OH. We do not have alpha hydrogen. No alpha hydrogen means no aldol. No aldol, here we have to do Cannizzaro. Okay, so the smaller one is converted to carboxylic acid salt and the bigger one is converted to alcohol. ठीक है, alcohol. Now we have CH3, CH2, Br, NaH and DMF. So see, we have CH2OH and here we have OCH3. So we have CH3, CH2Br, NaH, DMF. So DMF tells us that it is a nucleophilic substitution 2 reaction, right? This is SN2 reaction. So if we do SN2 reaction, so what happens over here? See, first this H minus, NaH. So we have H minus abstract this proton, and when we abstract this proton, the electron of this one shifts towards here, O minus. So we will have O minus. O minus attacks over here and Br leaves. So ultimately we have OCH3, then CH2, O, CH2, CH3. Clear? Okay. Now we have HI and heat. So HI. So this is the reaction of ethers. So what happens? In the first one, we get CH2, OH positive, CH2, CH3, and here also we write OH positive and CH3. Next step, I minus attacks on this and this leaves, because here we can form benzylic. This is benzylic position, here attack can happen, right? And here I minus attacks on this CH3 and this bond breaks, because I minus cannot attack on benzene ring. We have discussed similar kind of reactions in ethers. Okay, so from this we get CH2I and here we write OH From this we get CH3I, and from here we get CH3 CH2OH. Okay, so this is going to be the major product. So what is the answer? Option 3 is going to be the correct answer. Okay, now next question. The compound A in the following reaction is this. We have to find A, and we have this compound final, we have this. So it means we have to do reverse reactions, we have to do reverse reactions. So let's do it. So D, how can we form D? And this is barium hydroxide and this. So it means this is aldol. How can we form C? By Cannizzaro, now C plus D, here we have ozonolysis. So B must be alkene. Okay, if B must be alkene, so here we have alkene. So A is going to be what? A is going to be what? So what we are going to do, how to do this? So see, aldol, we have CH3, C, CH3, then double bond CH and C double bond O, CH3. So we have to do retroaldol, break this bond. Here carbonyl group is present, so here we write oxygen. So we have CH3, C double bond O, CH3, and here we write CH3, C double bond O, CH3. So this is by retroaldol. Okay, so this is my D. Now let's form C. So we have COO minus K plus CH2OH. Now this is formed from CHO, because one carbonyl compound is converted to carboxylic acid salt and another one is converted to alcohol. So we should be having two molecules of benzaldehyde. So this must be C. Up now we can combine C and D to get B. So what is C? C is CH3, C, CH3, double bond O. This is D. And what is C? C double bond O, H. Now what we are going to do? Join these carbon. Join carbon by double bond. So we form CH3, C, CH3, double bond C, H, and so this is going to be B, right? This is B. Up now we have concentrated H2SO4 and heat. So this is formed from concentrated H2SO4 and heat. So it means we should be having alcohol. No, we should be having alcohol. So which alcohol we should be having? So see, we can write CH3, C, CH3. Okay, we can write CHOH, and then here we write, here we write this one. Okay. Acha, now one more thing. Here we have from Grignard reagent we get alcohol. From Grignard reagent, which is CH3 MgBr, we get alcohol. Up now if you look in the options, we have all ketones, all ketones. So from ketones we get 3 degree alcohol basically. So it means here alcohol must be 3 degree. So here we put OH over here, and here we have CH2 and this. Okay. Now this is formed from CH3 MgBr and H2O. So it means one of the methyl group is due to Grignard reagent, right? It is due to Grignard reagent. So A ko how do we form? A is going to be this one, CH3, C double bond O, CH2, and here we have phenyl ring. So this must be A. So let's compare this. So we have C6H5, CH2, C double bond CH3. So option 3 is going to be the correct answer. Okay. Now let's do next question. Simple question, reagent based question. So here only keto group is reduced to H. Rest are same. So which group we are going to use? This is Wolff-Kishner reduction, right? This is Wolff-Kishner reduction. So we have two reagents now, either Clemmensen reduction or Wolff-Kishner reduction. So option 2 is going to be the answer. So Wolff-Kishner reduction reduces carbonyl to alkenes. Okay, now next one. We have this ZnHCl and double bond. So first one is the Clemmensen. Clemenson. So from Clemenson we get H and H, and then we have Cr2O3 and 773 Kelvin and 10 to 2018. So this reagent is aromatization reagent. Aromatization. So it means we are going to form aromatic ring. So 1, 2, 3, 4, 5, 6. So we will form 6-membered ring, and on one carbon we write CH2CH3. So on the basis of that, option 3 is the correct answer. Okay. Now, next question. We have a pH, double bond, and this is CH3. This is what? NaOCl. What is this? NaOH plus Cl2. It gives NaOCl, right? It means we have to form haloform reaction. So for haloform reaction, we should be having methyl ketones. So methyl ketones are there, right? So what we are going to do, here is a trick, just break this. So we write phenyl double bond O minus and Na plus CHCl3, chloroform. We are going to form chloroform. Okay, bete? That's it. Then we have SOCl2. We have what? SOCl2. So we write phenyl double bond and here Cl. Chlorinating. Matlab we have to understand कि in this one step should be this OH. ठीक है? One step should be this OH. ठीक है? Then SOCl2. So OH is replaced with Cl. ठीक है? OH is replaced with Cl, and then we have aniline. Aniline is what? NH2. And here we have pH double bond O Cl. So what we are going to do over here, just remove HCl, hydrogen and Cl. Just remove HCl. So we write NHC double bond O pH. ठीक है? So this is also the reaction of aniline. ठीक है? With nitrogen and derivatives, generally we remove water, HCl and other small molecules. So answer is going to be बच्चे option number 1. Okay, option 1. Next question, we have which of the following reagent is used for following reaction? So alkane is converted to aldehyde. This is the reactions in NCERT 11th. ठीक है? Oxidation reaction. Hydrocarbons chapter. Alkane to aldehyde. So we have what? Molybdenum oxide. Answer is going to be molybdenum oxide. With manganese acetate, we get carboxylic acid. With copper at high temperature and pressure, we get alcohol. ठीक है? And if we have 1 degree तो नहीं होता. But generally with potassium permanganate, we get carboxylic acid. But if we want to oxidize alkane to aldehyde, so we use molybdenum oxide. So that is the reaction of selective oxidation. Selectivity of catalyst and all. Now, next question is this. Major product in the following reaction is. So see, HCO positive है. So we can write H2O in the presence of H plus बच्चे. So देखो, we have two possibility. One possibility is this कि we have CH3 over here, ठीक है? And this carbon forms bond with hydrogen and we have carbocation formation over here. Right? One possibility is this. Another possibility is that कि this oxygen forms bond with the H plus. ठीक है बेटे? ठीक है? अब now what happens? If this bond comes over here, so we will have CH3 and here we write OH and this is positive. ठीक है? And if we form this one, so we have double bond and CH3 and we have OH. When we form this compound, this is going to be non-aromatic, right or wrong? But when we form this carbocation, this is very stable carbocation, है ना? Stable carbocation, because here we have dancing resonance. Dancing resonance is there. This bond shifts over here. ठीक है? अच्छा, dancing resonance just उसको भी भूल जाओ. Let's forget about this. But why this is stable? Because this is going to be the aromatic. This is going to be aromatic, because in dancing resonance we should be having cyclopropyl group. Here we have double bond also. So देखो, every carbon is sp2, and here 4n plus 2 is equal to 2. So n is equal to 0. So this is going to be aromatic. That's why the major is going to be fourth one. ठीक है? Major is going to be the fourth one. Clear? That's it. ठीक है? Or we can say oxygen can attack over here. An electron of this one shifts over here. Ultimately, this is a reversible reaction. So answer fourth is the correct answer. Next, the major product of the following reaction is, so we have C double bond O CH3, and here we have CH3. Alkaline KMnO4. So देखो, carbon is bonded to oxygen. Here carbon is bonded to hydrogen. So oxidation to carboxylic acid. If we have C H oxygen pi bond in the presence of alkaline KMnO4, heating, right? So this is converted to carboxylic acid. So option 3 is the correct answer. Okay, option 3 is the correct answer. Now, we have completed so many questions on the basis of chemical properties of carbonyl compound. Now we are going to do questions on the basis of chemical properties of carboxylic acids. Okay, so let's do the question number 1. Question says compound X undergoes following sequence of reaction to give the lactone Y. Okay. Now we have the product and we have to find out the reactant. It means we have to do the reaction from backwards. So see, we have OH. This is double bond O. This is O. And here we write this. So cyclic esters are called lactones. है ना? Cyclic esters are lactones. Now, if we have the ring formation, then that is due to the presence of carboxylic acid and OH, right? Ring formation, then that is due to the carboxylic acid and OH. Okay, and we know that we have KCN, so it means before that we should be having CN. CN on hydrolysis gives carboxylic acid. So, if I break this bond, so here we put OH and here we put H. So, it means we get double bond this and here OH, then CH3 and this OH. Okay, so this is going to be the previous product. Then we have KCN alcoholic KOH. Ab KCN, this is the carboxylic acid na. It means in this place we have to put cyanide, we have to put CN. So if we put CN in this place, so we write CN and then methyl and here we write OH. Clear? Okay. Now we have HCHO and KOH, right? HCHO and KOH. How to do this? What should be the product? Yeah, what should be the reactant? So in this question now, first what we are going to check is how many carbon atoms we have over here. So see, in this we have how many carbon atoms? We have 1, 2, 3, okay, and 4 carbon atoms. And if you see the reactant, we have 4 carbon atoms over here, and 1 carbon is bonded to 2 methyl groups, CH3 and CH3. Okay, so that's why now one more, we have 4 carbon atoms in this also, 1, 2, 3, 4, but we need 2 methyl groups on 1 carbon. So our most possible or most probable answer is going to be option number 1, but we have to check. So just for example, if we have CH and here we write CH3 and C double bond OH, right? C double bond OH. Okay, bache? Okay, fine. So how to do this thing? We have HC double bond OH and in the presence of KOH, So if you see over here, let me take CH, not CH, this is going to be H. Okay. So here we have alpha hydrogen. Okay, this is alpha hydrogen. Alpha hydrogen is available. So first, what is going to happen? We are going to do aldol. So it means first we are writing CH3 CCH3 minus C double bond OH. Then it is going to attack on carbonyl carbon present in methanol. Okay, so we have this kind of situation. So we write CH3, CCH3, CH3, CH3, and yeah, fine. So we can say that we are going to write CH3, CCH3. This is C double bond OH, and here we write CH2O minus. Then in the presence of water, what we are going to write? We are going to write CH3, C, CH2OH, then CH3, and here we write C double bond OH. Clear? C double bond OH. Then we have cyanide. Yeah, we have alcoholic KCN. So alcoholic KCN. So KCN attacks on this, and we get CH3, C, CH2OH, then CH3, COH, H, and here we write CN. CN on hydrolysis gives carboxylic acid, right? CN on hydrolysis gives carboxylic acid. On hydrolysis, we get this one. CH3, C, CH2OH, CH3, COH, and here H, and this is C double bond OH. Now, removal of water. So, removal of water, it gives us cyclic lacton, and we get 5-membered ring. See, 1, 2, 3, 4, and 1 oxygen. So, we get 5-membered ring. So, this is possible, and we have this situation only, right? We have this situation only. Okay. So, see, what do we write over here? Okay, fine. Okay, na? So, we are going to write this thing. Achha, here must be what we can write here. This is the OH now. Here we have to put OH. Okay, that's it. The closest option is option number 1. Okay, we get this answer only. You can compare this. Okay, now let's do next question. So next question says the correct sequence of reagents for the preparation of Q and R is. So we have phenyl C double bond OH plus phenyl CH2OH. Oh, in this we get carboxylic acid and alcohol. So that is after Canizero. And for Canizero, we need concentrated base. So last में तो we should be having concentrated base. Up now we have to prepare this 1, 2, 3, 4, 5, 6, 7. ठीक है? So what we are going to do, we have to convert this hexane ring into the aromatic ring or 6-membered ring. So for that, reagent is going to be Cr2O3. This Cr2O3 is used in aromatization. ठीक है, aromatization. Then what happens? We get 7-membered है, so we get toluene from this CH3. Up now, toluene on reaction with CrO2 Cl2, we get CHO. है ना? We get CHO. We have two reactions. Like this is a reaction with chromyl chloride, and then in the presence of water, we get CHO directly, right? Name reaction is there, Itard reaction and all. So we get benzaldehyde, or we get aldehyde group. Then we have concentrated NaOH and SO positive, and it will show Canizero. It means most probable answer is going to be option number 1. Clear? That's it. Now moving on to the next question, we have this situation. Fine. H plus. So we have this double bond OH, and we have OH, C double bond OH, this and this. Up now H plus is there and nothing else is there. So what to do over here? So first what we'll do, because we can do nucleophilic attack. So nucleophilic attack के लिए we have OH. This is available for nucleophilic attack. ठीक है? So this oxygen takes this H plus, and we have OH double bond OH, and this is positive, and here we write H, and then COOH, OH. ठीक है. Now next, this oxygen lone pair attacks on this carbon and electron of this bond shifts towards OH. ठीक है. So by doing so, we get OH. This is O, H positive, and we write C double bond OH, right? Here we write C double bond OH. Now what we can do? We will remove water, है ना? Let's remove water. So just remove water. So after loss of water, we get 1, 2, 3, 4, 5. 5-membered ring. So we get 5-membered ring. So we get O. Then here double bond O. This is going to be O. Like this. And then we have this situation. Right? So now if I want to compare this, so this is going to be, if this is the oxygen number 1, so this is 1, then double bond 2, then 3 पे we have 2 methyl group, then oxygen 4, and then 5 पे we have this group. ठीक है. So answer is going to be option number 2. अच्छा, अब ना point is this कि what to do over here, we have OH, so H plus automatically leaves. H plus automatically leaves to form oxygen. Clear? That's it. Now next question. Question says in a reaction we have this OH, C double bond O, OCH3. Okay, we get this from OH and C double bond OH. Oh, what is this process? Acid is converted to ester, right? Acid is converted to ester. So this is going to be esterification. For esterification, we should be having methanol and H plus and heat. So why should be this? And why should be, we have this option, this option. Okay, and then OH, COH, X gives this OCOCH3. This is called protection, है ना? This is called protection. Or this happens in the presence of acetic anhydride generally, right? Acetic anhydride generally. ठीक है? Because if we have CH3, C double bond O, C double bond O, CH3. So what happens? This oxygen lone pair, yeah, this oxygen lone pair attacks on this carbonyl carbon and this is going to leave. Okay, and we get this. So acetic anhydride. So as per this, we have option number X and Y we have to find out now. So X is going to be this and Y is going to be CH3OH and H plus. Okay, now next question. Let's do next question. We have major product P formed in the following reaction is. So we have this situation, double bond OH. We have Br2 in the presence of NaHCO3. So first of all, what happens? NaHCO3. NaOH, it is formed from NaOH and H2CO3. Okay, so this is going to act as a base. Okay, now base abstracts this hydrogen. So when base abstract this hydrogen, we get O minus. Now O minus is going to act as nucleophile. So now nucleophile hai. One more thing, we have Br2. So Br2 attacks over here. Br2 attacks on double bond. So what we can write? We can write कि here we have this formation. Br positive and this. Okay. So first step is this bromonium ion. Up now what happens? O minus reacts on the carbon and breaks the bromonium ion ring. So O minus can attack over here and electron of this bond shifts to Br. By doing so, we have 1, 2, 3, 4, 5. We will have 5-membered ring. Acha, now the possibility is this कि अच्छा ठीक है, why not 6-membered ring and all? Why not 6-membered ring, right? तो here 6-member ring नहीं है because in the option we do not have 6-member ring. अब now Br minus, why Br minus cannot attack? Because intramolecular attack is faster, right? Br minus cannot attack. Why? Because intramolecular attack is faster. Intramolecular attack is faster. So that's why what we are going to do, we are going to attack over here, and electron of this bond shifts to Br. Or this is also as per Markovnikov. So we have 5-membered ring बच्चे. So 5-membered ring, and on second we have double bond O, and on fifth we have CH2Br. ठीक है. So option third is going to be the correct answer. ठीक है. Now next question, we have this C double bond O NH2, this LiLH4 and H3O positive. Okay. ठीक है. Up now we know that this ketone is reduced to alcohol, right or wrong? This ketone is reduced to alcohol. Okay बेटे, एक मिनट, just give me a moment. Yeah, ठीक है. ठीक है, alcohol, and we have C double bond O NH2. So amides are reduced to amines. That's it. So as per this, we have option number 3 as the correct answer. ठीक है बेटे, as per this, we have option number 3 as the correct answer. Now next, SOCl2. So SOCl2 function is going to be, this is double bond OH. In place of OH we are going to put Cl, then RNH2. So what you are going to do, just remove HCl, one hydrogen and one Cl, and we get double bond NHR. ठीक है. Then we have LiLH4. LiLH4 reduces amides to amines, so we get CH2NHR. Okay bete, CH2NHR. Next, that is LiLH4 H2 positive, so we get the same thing. Okay. So fourth option is going to be the correct answer. That's it. Now next question, we have this CH3 and OCH3, and we get CH3 and OCH3, and CH3 is converted to carboxylic acid, right? CH3 is converted to carboxylic acid. So we have what? Alkaline KMnO4. If carbon is bonded to hydrogen, pi bond and oxygen, then that is converted to carboxylic acid in the presence of alkaline KMnO4, right? So option 3 is going to be the correct answer. Next question, we have this double bond O, C double bond O, CH3 and I2NaOH. So this will show iodoform reaction. Iodoform reaction. So what happens in iodoform? So we should be having methyl ketones. Already discussed this question, but the type of question. So just break this. So when you break this, so here we do not have phenyl ring. So cyclohexane ring, then double bond, and here we write double bond O minus Na plus, and we write CHI3. ठीक है. Then we have H plus. So H plus say we form carboxylic acid. Up now heating is there. So this is alpha and this is beta. This is beta keto acid. So beta keto acid on heating removes CO2. ठीक है. Beta keto acid on heating removes CO2. So we get double bond O, and here we write H. ठीक है. So we get yellow PPT of CHI3 and cyclohexanone. So option C is going to be the correct answer. Now next question, the most suitable reagent for the given conversion is. So the most suitable reagent for the given conversion is, how to solve this? So see, देखें, amides remain amides, C double bond O CH3 remains this, cyanide remains cyanide, and COOH, it means carboxylic acid, is converted to CH2OH. अब now if you don't know the function of any reagent, मतलब if you don't know how to relate it, so just use the elimination method. If we use NaBH4, then it is going to reduce this group. मतलब this group is reduced. Here we should be having alcohol. तो ये नहीं हो सकता. ठीक है बेटे. H2 palladium can reduce cyanide to CH2NH2. Okay. And CONH2 को भी CH2NH2 amines में. LiLH4 reduces all. So last option is going to be B2H6. So B2H6 is the option. So what happens? B2H6 can reduce carboxylic acid to alcohol. Okay. Next, the major product of the following reaction is. So we have CH3, CH double bond CH, and this is C double bond O and OCH3. So LiLH4 reduces esters to alcohol, right? Reduces esters to alcohol. So what do we write here? CH3, CH double bond CH, then CH2OH plus CH3OH. ठीक है, CH3OH. Clear? That's it. So the answer is 2. Okay, so the answer is 2. Now, next, the major product obtained in the following reaction is, so LiLH4 excess है. So see, this is carboxylic acid. So carboxylic acid is converted to alcohol, right? Carboxylic acid converted to alcohol. This is keto group. Keto group is converted to alcohol. So here we get 2 degree alcohol. Here we get 1 degree alcohol. ठीक है? Then we have NO2 group. So NO2 group is reduced to NH2 group. Right? NO2 group, it is reduced to NH2 group. So what is going to be the answer? So answer is going to be option number 3. See, we get CH2OH, then NH2, and here we write OH. Okay, that's it. Now, next question. So we have this and we have dibyl H. So dibyl H converts esters to aldehyde. Right? It converts esters to aldehyde. So what do we get? We get, here we have this. Okay. Then we write this. Here we write OH and here we write CH2 CHO. Okay. On the basis of that, option 2 is going to be the correct answer. Okay, bete. Option 2 is going to be the correct answer. Okay. Now next. H2SO4 catalyst hai, and then we have CHCl3. Okay, so how to do this question? So see, H2SO4 catalyst and CHCl3. So what we are going to do over here, so we have OH, then we have CH2, this is OH, and this is C double bond O, OET. Ab, can we write this one? Ki oxygen can attack on this carbonyl, carbon and OET leave. By doing so, we have 1, 2, 3, 4, 5, 6, 6-membered ring. And we know that intramolecular attack is faster than intermolecular attack. Right? Intramolecular attack, it is going to be faster than intermolecular attack. Okay? So what we do? We write OH and here we write oxygen and here double bond. Clear? Okay? Do we have any other situation? Any situation? What is the role of CHCl3? So basically, we CHCl3 say we get dichlorocarbon and all, but that is in the presence of basic medium. Otherwise, we do not have anything else. Okay, one more thing can happen. If we have CHCl3 and if KOH is given, then we can do the Reamer-Teamer reaction. So at this position, we can put CHO. But here nothing is given, and if you look for the options, we do not have that kind of option. So option 1 is going to be the correct answer. Okay. Now next question. Naming. So RCOCl, RCHO. This is Rosenmund. Right? This is Rosenmund, and for Rosenmund, we have 2. So A can be matched with option number 2 and 2. So 1 and 4 can be the correct option. Okay. Now let's look for B. So we have RCH2COH and RCHCOH, alpha halogenation. This is HVZ, Hell-Volhard-Zielinski reaction. and this happens in the presence of red phosphorus, Cl2 in red phosphorus, so B can be matched with fourth. So on the basis of that, option B is last, option 4 is going to be the correct answer. ठीक है. अब now this is amide, amides are converted to amines, so this is Hoffman bromamide degradation, and RCOCH3, so carbonyl compound is converted to alkane, so that happens in the presence of Clemmensen reduction. ठीक है, तो C can be matched with first and D can be matched with third meter. Clear? Now let's do next question. So question says an organic compound A, molecular formula C10H20O2, was hydrolyzed with dilute sulfuric acid to give a carboxylic acid B and alcohol C. Okay, so it means this must be ester. Okay, so oxidation of C with CrO3H2S4 produced B. Okay, so C matlab ester, if A is ester, so ester on hydrolysis, right, on hydrolysis gives B and C. C is alcohol, and this alcohol in the presence of CrO3H plus produced B. Which of the following structures are not possible for A? So what you need to do, you have to do the dissociation and then find out which of the structure is not possible. So what we can write is, suppose we have option 1, we have CH3, CH2, CH, CH3, O, C, it's not O, we can write C double bond O, O, CH2, CH, CH3 and CH2, CH3. So on hydrolysis, we write OH over here and H over here. So CH3, CH2, CH, CH2, CH, CH3 and CH2OH. On oxidation, it gives this carboxylic acid, na, which is CH3, CH2, CH, CH3, C double bond O, OH. So you have to do this thing, right? So if you break over here, so from the second one, from second option, you get this CH3, CH2, CH, CH3, COOH and CH3, CH2, CH, CH3 and here we write CH2OH, which is further oxidized to give carboxylic acid. So this can be correct. If you look for this, so CH3, CH2, CH2, COOH plus CH3, CH2, CH2, CH2OH, which are further oxidized to give carboxylic acid. But here we have issue. Why? Because A is going to be C10. We should be having 10 carbon atoms, but here we have 8 carbon atoms. So this cannot be correct. So option 3 is going to be the correct answer. Right. If you see option number 4, again we get this thing. See, we write CH3, but complete, but just write it. Let me write it for you. So we get CH3, C, CH3, CH3, and this is going to be COH, COH plus CH3, yeah. So we get CH3, C, CH3, CH3 and then CH2OH, which further oxidize to give carboxylic acid, right? So here also we have how many carbon atoms? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this can be true. Here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 can be true. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 can be true. Right. So third option is not true. Why? Because we have 8 carbon atoms. Right. Okay, students. So we are moving to our last problem type, in which questions are going to be from the test, distinguished test, like tolerance test, failing test. You know, we have so many tests. So we are going to do questions from here, from that part. So the first question says the number of compounds giving red coloration with steric ammonium nitrate test. So steric ammonium nitrate test is for alcohols. So if we have alcohols, then we get red color. Red coloration will be there, right, for first test. And second, positive iodoform test. So positive iodoform test, we should be having this group or we should be having this group, right? So these groups generally give iodoform. So question says which gives both test. So see, here we have CH3 C double bond O. So it gives second test. It gives second test. It gives second test, but not first. So ये नहीं. Here we have CH3 CHOH. So here we have alcohol, so it can give first test, even it can give second test. So this can be our option. If you see, this is aldehyde. Okay, this is aldehyde, but we have CH3 C double bond O group, so it can give second test but not first. Here CH3 CHOH, so it can give second test, even it can give first test due to the presence of alcohol. So it will not give any test. Here it will give first test due to the presence of OH. Here CH3 CHOH, so it can give second test, even it can give first test. ठीक है, अब तो नहीं, it can give only first. ठीक है बेटे. So the point is that out of all which can give both tests, so that is going to be one is going to be this, second is going to be this, and third is going to be this, right? So answer is going to be 3. Okay, now let's do next question. So next question says a tri-substituted compound A tri-substituted C10H12O2 gives neutral FeCl3 test. Neutral FeCl3 test means presence of phenolic group. Phenolic group should be present, होना चाहिए, right? Treatment of compound A with NaOH and CH3Br, NaOH and CH3Br gives C11H4O2, right? It gives C11H14O2, and with hydroiodic acid gives methyl iodide, right? Gives methyl iodide, and with hot concentrated NaOH gives compound B, and with hot concentrated NaOH gives compound B, which is C10H12O2. Compound A also decolorized alkaline KMnO4. That is the presence of double bond. Yeah, presence of double bond is there. Up now we have to find out number of pi bonds present in the compound A. So see, we have so many approximations, we have so many compounds for that. So how to do these type of questions? For these type of questions, you need to find out the degree of unsaturation. Degree of unsaturation, right? So the question says ki number of pi bonds you have to find out in A. So what you are going to do? You are going to find out the degree of unsaturation in A. ठीक है? Degree of unsaturation in A. Formula for degree of unsaturation is du is half 2 into number of carbon atoms plus 2, right? Plus 2, then plus number of nitrogen atoms minus number of hydrogen atoms and minus number of halogen atoms, right? So in that way you can find out the degree of unsaturation. So that is going to be half 2 into number of carbon atoms. We have how many carbon atoms? 10, and hydrogen 12. So 2 into 10 and hydrogen 12 plus 2, we have to write plus 2. So half 20 minus 12 plus 2, which is equal to half 22 minus 12. So we have 5, right? And degree of unsaturation we can also find by number of pi bonds plus ring. Up now this compound can give neutral FeCl3 test, yani phenolic group is there. So it means 1 degree of unsaturation is due to the ring. So total pi bonds are going to be 4. ठीक है, 1 degree of unsaturation is that due to the ring, so total pi bonds they are going to be 4. The answer is 4. Okay, now next question. So next question says the number of molecule which gives haloform test among the following molecules. Again we have to look for this option, है ना, or CH3 CHOH. So in this we have this, so it can give, ठीक है, in this we have this, so it can give CH3 CHOH, it can give, rest cannot give. So 1, 2 and 3, so we have answer equal to 3. Okay, answer equal to 3. Clear? Next question is, among the following, the number of compounds that will give positive iodoform test. Again we have to look CH3 C double bond O this and CH3 CHOH this, but for that we should form the structure. So the first structure is 2-methyl, 1-methyl butane 2 on. So 1, 2, 3, 4. So 2 butane and 1 phenyl. Okay. Second option is 2-methyl butane 2 all. 1, 2, 3, 4. 2 butane and this is 2-methyl. C option is 3-methyl butane 2 all. 1, 2, 3, 4. So this is OH and 3 pe we have methyl group. Now fourth, 1-methyl ethanol. 1-methyl ethanol, so which is phenyl CHOH and that is CH3. Okay. So 1, 2, 1 phenyl ethanol. Okay, bete. Now next, E, option E, 3,3 dimethyl butane 2 on. 1, 2, 3, 4, 2 on and 3,3 dimethyl. Right, so let's find out in that first. So we do not have this kind of group. So this does not give. We have CH3, CHOH group. This group is present, so this can give. We have CH3, CHOH. Acha, now one more thing. Here, this is not CH3, CHOH. This is not this, na. This is CH3, COH. So this cannot give. Here we have CH3, CHOH. Yes, it can give. Okay? Here we have CH3, CHOH. Yes, it can give. Now look for E. In E, we have CH3, C double bond O. So this is the methyl ketone. We have methyl ketone, so E can give. Now F1, 1 phenyl propane 2 all. F 1 phenyl propane 2 all. So 1 phenyl and propane 2 all. So again we have CH3 CHOH group. So this can give. Right? This can give. So total options 1, 2, 3, 4. So total answer is going to be 4. Answer is 4. Now let's do next question. Okay. List 1 reagent used and list 2 compounds with functional group detection of functional group. So we have alkaline solution of copper sulfated sodium citrate. So this is going to be the Benedict. So Benedict reagent is used to detect aldehyde group. So we have aldehyde group in option number 3. So it is used to detect 3. Now second, neutral FeCl3. So neutral FeCl3, that is for phenolic group. For phenolic group means OH should be bonded to benzene ring. So do we have this option? Yes, we have option in fourth. So B can be matched with fourth. Now C, alkaline chloroform, so CHCl3 and OH minus. So that is for 1 degree amine. 1 degree amine. If we have 1 degree amine, so in the presence of this, it is converted to R and C, false smelling compound isocyanide. This is carbylamine reaction. So this is 1 degree amine because nitrogen is bonded to 1 carbon, so 1 degree. So C can be matched with second. Okay, so A third, B fourth, C second. On the basis of that, we have option number 2 as the correct answer. Now D, potassium iodide and sodium hypochlorite. So potassium iodide, which is Ki, and sodium hypochlorite NaOCl. So NaOCl, haloform reaction, right? So we should be having CH3, CHOH. So it means D can be matched with option number first. Okay. Now, next question. Next question says the mass of ammonia produced when 131.8 kilogram of cyclohexane carbaldehyde. So this is cyclohexane carbaldehyde and this is 131.8 kilogram. Undergoes tolerance test. So tolerance test is silver ammonical nitrate solution, which is NH32, and here we write OH. So CHO is converted to CO minus. Then we have silver ka precipitate, ammonia and water. So obviously we have to balance this equation. So on balancing you get 2 over here. Here you write NH4 positive, 2 a here, 3 NH3 over here. ठीक है. अब now we have mole concept reaction, mole concept question, right? So 1 mole of this gives 3 mole of ammonia. So we have to find out number of moles. So number of moles 131.8 given mass upon molar mass. So 131.8 and molar mass is going to be 112. ठीक है. So अब we know that but it is in kg, so we write 1000. Okay bete. So we know that 1 mole of this cyclohexane carbaldehyde gives 3 mole ammonia, na? Okay bete. So if we have 131.8 into 1000 upon 112 mole of this, it gives 3 into 131.8 into 1000 upon 112 mole ammonia. We have to find mass. So mass के लिए number of moles into molar mass. So what we are going to do? एक मिनट, just give me a moment. What we are going to do over here? Yes. 3 into 131.8 into 1000 upon 112 into 17 gram ammonia. We have to find out this mass in kilogram. So 3 into 131.8 into 1000 upon 112 into 1000 into 17 kilogram ammonia. Right, up now you have to solve it. When you solve it, you get 60 kg as the answer. Okay, 60 kg is the answer. So here you have to report your answer in terms of 60. Okay, bache? That's it. Now let's do this question. In tolerance test for aldehyde, the number of electrons transferred to the tolerance formula. So see, we know that we have RCHO, so we require 2 mole of silver ammonical nitrate. Already discussed above, है ना, 2 moles. So up now Ag plus is converted to Ag in this. So it accepts 1 electron now. It accepts 1 electron. Ab we have 2 Ag plus, so it will accept 2 electron to form 2 Ag. So per aldehyde group, it should accept 2 electron, right? The answer is 2. So in that way you can solve. There is no, do not solve by different method. This is the easiest way to do this. Next, 2,4 DNP test can be used to identify DNP test, that is for carbonyl. So we can easily identify aldehyde. We can also identify ketone, okay? But aldehyde ke liye generally this test is there. Now, 2,4 DNP test, colored precipitate. It means carbonyl is present. Carbonyl is present. Aldehyde or ketone. Aldehyde and ketone. Iodoform test, yellow precipitate, हाँ दे रहा है भाई, बिल्कुल सही है. तो it means we should be having methyl ketones. Methyl ketones, or we can have this isopropyl alcohol, 2 degree alcohol, because 2 degree alcohol first oxidized to ketone. Understood? Then it undergo haloform reaction. Then azodite test, no dye formation. It means no coupling. So no coupling means no 1 degree ammonia, NH2, or 1 degree amine. 1 degree aromatic amine. So it means this cannot be true, this cannot be true, right? Okay, bete. Now we have the option 2 and 4th. 2 and 4th may iodoform test is given by this one. है ना, COCH3, methyl ketose. So option 2 is going to be the correct answer. Okay. Now moving on to the next question. We have O3 and then silver ammonical nitrate test. ठीक है. So after that we get 3 oxohexane dicarboxylic acid, COH, then CC, third, 1, 2, 3, 4, 5 and then 6. है ना, 4, 5, 6. And it absorbs 2 hydrogen molecule. It means 2 double bond are present. Okay, but third position we should be having oxo group. ठीक है, keto group. So let's do this. So what we are going to do? Just break this. So here we form CHO, but it is further converted to COH. Again, this is CHO, but it is further converted to COH because ozonolysis है. ठीक है. अब here we write HCHO, or here we write oxygen on breaking this. So here 1, 2, 3. Right. Third पे we have oxo group. Then 4, 5, 6. So option 3 is going to be the correct answer. From option 3, if you do ozonolysis and then silver ammonical nitrate test, then you get this. ठीक है बेटे? Okay. That's it. CHO है ना? CHO, first we get CHO, and on reaction with tolerance reagent, CHO is converted to the carboxylic acid. Right? So we have this option. There is no need to write all the reactions. You can easily do it that way. Now next, A on ozonolysis gives B and C. In the B we have yellow PPT. It means we should be having this group, either this group or CH3CHOH group. Ag2O silver mirror. It means silver mirror B we can form. ठीक है. Next, I2NaOH, no iodoform test. Then on reduction, C on reduction gives D, which on reaction with Lucas reagent gives turbidity after 5 minutes. Yani D should be 2 degree alcohol. So what we are going to do? We have to look for options. So if we look option number 1. So CH3, C, CH3, and this is a double bond. Then C, H, CH2, CH2, CH3. This is one. So just break it. तो oxygen oxygen, so we get CH3 C double bond O CH3, and here we write CH3 CH2 CH2 C double bond O H. Understood? ठीक है. So if this is B, because B can undergo iodoform, so this can happen, and this is C iodoform तो नहीं होगा, very good. But on reduction with LiLH4 we get CH3 CH2 CH2 CH2OH, which is 1 degree alcohol. So we cannot have this, right? We cannot have this. Now same, just look for this third option. So if you see third option, so we get double bond H. So CH3 C double bond OH, and here we write CH3 CHOH, right? OH, then CH2 CH2 CH3. Again, because both can undergo, matlab both can give iodoform. This cannot be true. Now let's look for D1. Let's look for D1. So when you break this, you get CH3 C double bond OH, and here you get CH3 CH2 C double bond O, and then CH2 CH3, right? CH2 CH3. So here no iodoform. This can give iodoform. So this is B, and this is going to be C. And ketone on reduction gives 2 degree alcohol, right? So fourth is going to be the correct answer. Okay. Now next question. An organic compound neither reacts with neutral FeCl3, yani no phenolic group. It means no phenolic group, nor with failing solution. It means no aromatic aldehyde. It, however, reacts with Grignard reagent and gives positive iodoform test. Iodoform देगा Grignard. तो पहले phenolic group should not be there. So this cannot be the answer. Okay. Now aromatic aldehyde. So this is aromatic. CHO. So this cannot be the option. Now we have only 3. So it can give iodoform test. So this group can give iodoform, right? CH3O iodoform. We do not have any group over here. No group in third. So option is fourth. And it can react with Grignard reagent also. See na, we can have C double bond O minus plus CHI3 on breaking this, and here we write double bond O, and Grignard reagent से R होगा कुछ, ठीक है, R होगा, and हाँ, so कुछ R होगा, R नहीं होगा, we have this one, sorry, OH and R from Grignard reagent and then C2H5. So this can react. So it means option 4 is going to be the correct answer. Okay. Now next question. Which of the following reacts with ethyl magnesium bromide and also decolorized bromine water? Decolorized bromine water means unsaturation is there. Unsaturation is there. Br to water. So it gives HOBr. Already discussed this in hydrocarbons. So we get OH minus and Br positive. So we should be having double bond. And it can react with ethyl magnesium bromide. So first we have to look for double bond which can reduce. So here we have 3 and here we have 4. Okay. So question says it can react with ethyl. It cannot react with ethyl magnesium bromide. No reaction with Grignard reagent. No reaction with Grignard reagent. But OH can react with Grignard reagent. Can react with Grignard reagent. Why? Because Grignard reagent is a base. So after reaction with Grignard reagent, it forms OMgBr. Okay, and we have RH. If we have suppose RMgBr as the Grignard reagent. Okay, and decolorized bromine water. So here we write Br and here we write OH. Okay, bete. So option 4 is going to be the correct answer. Okay. Now next question. Compound A C9H10O shows positive test against oxidation of A with KMNO4 KOH gives acid. Okay. Anhydride of B is used for the preparation of phenolphthalein. So first of all, phthalic acid anhydride, C double bond OH and C double bond OH. So it's anhydride when you remove water. So we get phthalic anhydride. So this is used to prepare phenolphthalein, discussed in alcohol, phenols and ether, previous chapter, right? We have discussed questions related to phenolphthalein. So question says positive iodoform test, it means methyl ketone should be there. So we have methyl ketones over here, here, here. So it can give iodoform. But the point is that On oxidation, it gives, if it gives iodoform, so here we write double bond O minus, and CH3 on oxidation gives C double bond OH. Now anhydride of this compound gives phthalic anhydride, so our option is going to be fourth. That is going to be the correct option. Okay, because we have a difference over here. Here we cannot form phthalic anhydride, right? Here also we cannot form phthalic anhydride. Okay, so important condition is that we should be forming phthalic anhydride. So that's it. Next, number of compounds from the following which will not dissolve in cold NaHCO3. It means not acidic, but will dissolve in hot NaOH. Hot NaOH means hydrolysis can happen. Hydrolysis can happen, and hydrolysis means water in presence of basic medium. It can happen. So carboxylic acid can react with NaHCO3 easily. So that is, it means ester should be present. Because what happened, OH minus can attack onto this carbon and OCH leave, right? So we should be having ester. So we have to look for ester. So see, here ester is present, here ester is present, here we can have ester. Okay? Only we have 3 esters. So 3 esters means total compounds. So that is going to be 3. Okay. So guys, we have finished another important chapter, that is aldehydes, ketones and carboxylic acid, and in the next video I will be taking some questions related to amines. If you like this video and if you enjoy the solving organic chemistry questions, then hit the like button and write down in comment section if you need any kind of help. If you want to join us, then everything related to the program and PracBee you can find out in the description box. Okay, so see you, bye, take care. We will see you in the next video.